You're watching NASA TV.
Good day from Mission Control in Houston and the International Space Station Flight Control Room as we begin our coverage today of U.S. Spacewalk number 76, the third spacewalk in the last 9 days for NASA astronaut Shane Kimbrough and European Space Agency astronaut Thomas Pesquet as they are preparing to venture outside of the Quest airlock once again to install, unfold and unfurl the second of two ISS rollout solar arrays that are being installed on the International Space Station to provide a total of 120 additional kilowatts of power to augment the electrical capability of the International Outpost. You are looking live inside the Quest airlock 1 month shy of its 20th anniversary of use on the International Space Station. On the right side of your screen is Pesquet. He once again is playing the role of EV1, or extravehicular crew member number 1, wearing the suit bearing the red stripes today. On the left is NASA astronaut Shane Kimbrough. He'll be wearing the unmarked suit as EV2, or extravehicular crew member number 2. These two astronauts, members of the Expedition 65 crew, are about to make their fifth spacewalk together. The first two spacewalks that they conducted were back in 2017. This is their third spacewalk in this series to install the new ISS solar arrays. This is the 241st spacewalk in the history of the International Space Station for assembly, maintenance, and upgrades. The 9th spacewalk out of the International Space Station this year, the 9th in Kimbrough's career, with a total of 52 hours and 43 minutes of spacewalking time to date. For Pesquet, this will be his 5th spacewalk, his 4 previous excursions in the vacuum of space totaling 26 hours and 15 minutes. The two astronauts have been suited up for the past couple of hours. They have been pre-breathing pure oxygen to cleanse the nitrogen out of their bloodstreams, preventing any condition known as the bends or decompression sickness from occurring when they step out into the vacuum of space. Most recently, they've been conducting what is called lightweight in-suit exercise protocols to slightly elevate their metabolic rate and hasten the dispersion of nitrogen out of their bloodstreams. They are all set to go, and in fact, you can see Kimbrough on the left being assisted by NASA astronaut Mark Vande Hei and Megan MacArthur in the foreground as they prepare to install SAFER units, or Simplified Aid for EVA Rescue units. Those are the jet-powered backpacks that each spacewalker wears all the time to help them propel themselves back to the safety of ISS structure in the highly unlikely event they would become untethered during the course of their spacewalks. The first two spacewalks in this series, conducted on June 16th and again last Sunday on June 20th on Father's Day, were designed to install the first of these two ISS rollout solar arrays. You can see in this replay the first of those arrays for the 2B power channel on the Port 6, or far port truss of the International Space Station, being unfurled after it was finally installed with a little bit of elbow grease to the mounting bracket, a mod kit as it is called, at the base of the mast canister on the Port 6 truss on the far left side of the International Space Station. These arrays are innovative new solar array designs that use high-strain one-piece carbon fiber composite material. The stored strain energy of the booms provides the deployment capability, and once they're deployed, the booms provide the array's structural stiffness and their strength. There's a series of bolts and restraints that have to be undone by the crew members during the course of the installation process to first tightly install the arrays onto that mounting bracket and then eventually deploy them. In the foreground right now is Space Station Commander Aki Hoshide from the Japan Aerospace Exploration Agency as he watches over Vande Hei and MacArthur prepare Pesquet and Kimbrough for their activities outside of the International Space Station today. The objectives today is to remove the second IROSA or ISS rollout solar array from its flight support equipment and translate it, move it. Pesquet will be hauling it at the end of the station's robotic arm that will be driven by Megan MacArthur over to the Port 6 truss mast canister and install it on a mod kit, as was the case during the first two spacewalks by Pesquet and Kimbrough. They will then prepare for the installation of that solar array on the mast canister and complete its installation and deploy it, unfurl it on the mast canister to complete the second of the series of ISS solar array installations. There will be 4 more solar arrays flown to the International Space Station in pairs, 2 additional pairs to be flown on SpaceX Cargo Dragon missions in the future. The next pair will be installed for the 4A and 3A power channels on the Port 4 and Starboard 4 truss of the International Space Station. The final set or final pair of arrays will be for the 3B and 1A power channels on the Starboard 6 and Starboard 4 solar arrays to complete the power augmentation for the International Space Station. These are not designed to replace what are called the legacy or the older solar arrays on the station, but rather to augment their power capability for the future delivery of science payloads and new modules to be launched to the International Space Station.
Okay, and now it's time for
these new solar arrays also have future application for future space exploration objectives for NASA. The new Gateway program is an outpost that will be launched to orbit the moon, providing vital support for a long-term human return to the lunar surface, as well as serving as a staging point for deep space exploration, a critical component of the Artemis program to return humans to the moon by 2024 and beyond. You can see a comparative graphic here that shows the heritage or legacy solar array wings that currently exist on the International Space Station and their dimension. The new IROSA or ISS rollout solar array wings, a derivative of that on the far right for PPE or the power and propulsion element for the Gateway program, will be a solar array that is wider, about the same length, but a heavier in mass solar array that will provide power for the Gateway elements. Each of these power and propulsion elements will have 2 rollout solar arrays available. Each of these new solar arrays for the Gateway program will produce about 60 kilowatts of power. The Gateway elements will use this power to move around the moon while performing lunar exploration support capability. Here in Mission Control, the Orbit 1 team of flight controllers has been working in the deep overnight hours, overseeing the preparation for today's spacewalk by Pesquet and Kimbrough. The EVA officer at the moment on console, Sandy Fletcher, has reported back to Flight Director Emily Nelson that we expect to begin the depressurization of the crew lock section of the 2-compartment Quest airlock at about 6:17 a.m. Central Time. That would put us right on the money, right on the clock, to begin today's spacewalk in the neighborhood of about 7 a.m. Central Time, a spacewalk expected to last 6.5 or so hours in duration to complete the installation of the second of the 2 ISS rollout solar arrays.
Make sure you go at in the timeline right now for us to keep pressing into safer dawning.
A-Firm, you have a go to continue, and one more bit of good news for you. I wanted to let you know that the 4 Bravo BGA is latched at this time.
Woohoo, that's great news. Thanks for sharing that with us. Go to continue.
As has been the case for the previous spacewalks, we'll be sharing views from helmet cameras that the two spacewalkers will be wearing throughout the course of today's excursion. Thomas Pesquet's helmet camera will have the number 20 in the lower right-hand corner of your screen. Kimbrough's helmet camera will bear the number 22. And they are both equipped with high-definition cameras on their helmets as well to provide up-close and personal views of the work that they'll be doing outside of the International Space Station. A short time from now, there'll be a handover of flight control teams here in Mission Control. The Orbit 2 team, the Execute team, will be on console for the spacewalk itself. Once it gets underway, you can see the roster of personnel for today's activities. The flight director who will be overseeing the spacewalk itself is Pooja Jesrani. She will be accompanied by what is called the Ground IV Capcom, or Spacewalk Communicator, Jenny Sidey of the Canadian Space Agency. She's an astronaut for the Canadian Space Agency. She'll be joined on console by veteran spacewalker and veteran astronaut Drew Feustel as well. Megan MacArthur, who is assisting Mark Vande Hei in the suit-up activities for Pesquet and Kimbrough. MacArthur will make her way to the robotics workstation inside the International Space Station and will drive the Canadarm2 robotic arm with Pesquet at the end of the arm to maneuver him into position as he hauls the second solar array over to the work site on the far port truss of the International Space Station, the P6 truss. This truss segment, this array, is being installed for the 4B power channel on literally the opposite side of the work site where the 2B array was installed and unfurled this past Sunday. This is Mission Control Houston. Thomas Pesquet, now equipped with his jet-powered backpack, again called a SAFER unit. The acronym for Simplified Aid for EVA Rescue has been moved into the outer compartment of the Quest airlock, the crew lock section. The innermost compartment, known as the equipment lock, populated there by Aki Hoshide and Megan MacArthur, about to affix the second of the SAFER units to the extravehicular mobility unit or spacesuit for Shane Kimbrough. All of this activity is the backdrop for another busy week aboard the International Space Station. This coming Tuesday, the Northrop Grumman Cygnus cargo craft, the SS Katherine Johnson, will be unberthed from the Earth-facing port of the Unity module of the International Space Station and maneuvered into position for a ground-controlled robotic release. That all taking place on Tuesday morning, June 29th. Our NASA TV coverage of that activity will begin at 11 a.m. Central Time, noon Eastern Time, for an expected release time of 11:25 a.m. Central, 12:25 p.m. Eastern Time. That will take place just 7 hours before the Russians launch the next unpiloted ISS Progress resupply vehicle, the ISS Progress 78, from the Baikonur Cosmodrome in Kazakhstan aboard a Soyuz 2.1A booster. The Progress loaded with almost 2 tons of food, fuel, and supplies for the International Space Station, to be launched at 6:27 p.m. Central Time on Tuesday, 7:27 p.m. Eastern Time, 4:27 a.m. Baikonur time on June 30th. Our coverage of the Progress 78 launch out of Baikonur, anchored here at the Johnson Space Center, will begin that evening at 6 p.m. Central Time, 7 p.m. Eastern Time. The Progress to arrive at the International Space Station for a docking on the evening of July 1st, and we'll be providing live coverage of that as well. As we watch Megan MacArthur assist in the installation of the Simplified Aid for EVA Rescue unit on the back of Shane Kimbrough's suit, assisted by NASA astronaut Mark Vande Hei, a reminder that we're taking your questions at hashtag AskNASA throughout the course of today's spacewalk, so that we can explain some of the intricacies of this excursion by Pesquet and Kimbrough and related topics associated with human spaceflight. A couple of questions while we have a moment here right off the bat. Many people are asking why the new solar arrays are not symmetrical. In other words, why are they a bit smaller than the legacy or existing solar arrays on the station? The answer is that we're not replacing the old solar arrays. We're simply augmenting their power capability. So the new arrays are only shadowing a portion of the older arrays, so they can provide an additional 20 kilowatts of power to the electrical output currently being generated by the older arrays. There are 8 power channels on the International Space Station. only 6 solar arrays are being installed in these first 2 and then 2 additional pairs for a total of 6 to accommodate 6 out of the 8 power channels. The selected power channels for the new arrays were chosen because of the high loads and the high demand for power that they generate for particular systems on the International Space Station. On Twitter, Kyle is asking how many solar arrays are there? There are 8 in all. How long are they? Well, we explained in a graphic a short time ago that the older solar arrays, known as the legacy arrays, are about 115 feet long by 38 feet wide. At the beginning of their lifetime, they each generated about 32 kilowatts apiece. On the Earth, they have a mass of 2,400 pounds apiece. The first pair of solar arrays were delivered on the STS-97 mission for the Port 6 truss, the same place where these first 2 new solar arrays, the rollout solar arrays, are being installed for power augmentation. These IROSA or ISS rollout solar arrays are about 63 feet long by 20 feet wide. They have a mass of 750 pounds apiece, and again will generate about 20 additional kilowatts of power at the beginning of their lifetime. For viewers on NASA television, our spacewalk coverage that's underway, now that Shane Kimbrough has also been moved into the crew lock section of the Quest airlock, we are running our spacewalk coverage uninterrupted on the public channel of NASA television. The media channel at the moment is being used and being held in abeyance for possible coverage coming up in the next hour of a sounding rocket launch out of the Wallops Flight Facility in Virginia. Once that's completed, the Spacewalk coverage will also air on the media channel, but for now, the Spacewalk activities leading up to an expected start of the Spacewalk about an hour from now is on the public channel only. This is Mission Control Houston. Once again, you're looking live inside the Quest airlock of the International Space Station. Shane Kimbrough and Thomas Pesquet are inside the crew lock section. Mark Vande Hei is also in there, helping to position the two spacewalkers for today's excursion outside of Quest to install, unfold, and unfurl the second of the two ISS rollout solar arrays. This one for the 4B power channel on the port 6 truss of the complex. The first of the two arrays installed and unfolded and unfurled this past Sunday for the 2B power channel, as the power augmentation of the station is well underway now. This the second of 6 planned ISS rollout solar arrays to be installed to increase the power capability of the International Space Station. A short time from now, the hatch between the two sections of Quest will be closed to isolate the spacewalkers in the crew lock. They then will begin the depressurization of the crew lock down to vacuum in a two-step fashion. First from 14.2 pounds per square inch of pressure down to 5 pounds of pressure per square inch. We'll take a pause to do systems and communications checks and leak checks on the two spacewalkers' suits before the depressurization continues down to vacuum. That then will be followed by final communications checks and the opening of the hatch to the Quest airlock. The official start of today's spacewalk, as it always is, will be measured at the time that the crew places their suits on battery power. This is Mission Control Houston. Mark Vande Hei now has closed and latched the hatch, separating the equipment lock section that he and Megan MacArthur are in.
Round 1, we are complete with steps 72 and 73.
Good morning, Megan and crew. Great to hear it. We copy. And we'll start putting the comm config into work, so the crew should have a heads up that there'll be hot mics shortly on Space to Ground 1.
Okay, Drew, we copy that. Great to hear your voice. Welcome to the Orbit 2 team, and many thanks to the Orbit 1 team for getting us ready.
They're still working their way out of the room, but they appreciate that.
The Orbit 2 team of flight controllers beginning a handover here in the flight control room here in Mission Control. The voice you just heard was that of veteran astronaut and spacewalker Drew Feustel. He will be the Capcom or spacecraft communicator talking to Megan MacArthur and Mark Vande Hei and the two spacewalkers who are now on the other side of the hatch in the crew lock section of Quest up through the time that the depressurization of the crew lock section of Quest is complete. Then communications chores will be handed over to Canadian Space Agency astronaut Jenny Sidey, who will be the voice and the choreographer talking the two spacewalkers through their procedures throughout the course of today's spacewalk. This is Mission Control Houston. As you can see, we are watching the activities in the Quest airlock of the International Space Station. Mark Vande Hei on the right. On the left is Megan MacArthur. They have completed the preparations for Shane Kimbrough and Thomas Pesquet to begin the 241st spacewalk in support of space station assembly, maintenance, and upgrades. Today's activities, the third in the series over the past 9 days, to install today the second in the series of ISS rollout solar arrays. This one also on the P6 or Port 6 truss of the International Space Station. This one for the 4B power channel on the opposite side, to which the 2B channel ISS solar array was installed and unfurled this past Sunday. The two spacewalkers are suited up. They have pre-breathed pure oxygen to cleanse the nitrogen out of their bloodstreams. They've been moved inside the crew lock section of Quest. The hatch, of course, now closed as we stand by for the start of the depressurization of the crew lock about 6.5 minutes from now, taking the crew lock down to vacuum as the precursor to the opening of the outer thermal cover and the outer hatch to Quest, and the initiation of battery power on the two spacesuits for Kimbrough and Pesquet that will start the clock running and the official start of today's excursion. This is the 9th spacewalk for Shane Kimbrough, the 5th for Thomas Pesquet, and the 9th to be conducted out of the International Space Station this year.
Station Houston, Space to Ground 1, just a heads up for the crew. You guys are now hot mic. Good morning, Taman, Shane. Looking forward to seeing you guys outside today.
Hey, good morning, Drew. It's good to hear your voice. And they're not out yet, but we heard they're out the door. Congrats on the Orbit 1 team for getting us ready.
We'll pass that along.
Thanks.
Shane, on the UIA, you can check the depress pump power is off, and the depress pump enable LED is on.
The depress pump power is off, enable LED is on.
And Houston, we are standing by for your go for the crew lock depress cue card.
Copy, stand by. We need to get a go around the room, and then we'll be back with you shortly. And Houston, or station, just a heads up, we're showing still about 5 minutes for the go for depress anyways with the timer, so we'll be standing by for that as well.
Megan MacArthur on the left side of your screen was one of the crew members launched to the International Space Station on a SpaceX Falcon 9 rocket aboard the Crew Dragon Endeavour back in April. just 2 weeks after Mark Vande Hei, who's on the right side of your screen, launched to the station with Oleg Novitsky and Pyotr Dubrov on the Soyuz MS-17 spacecraft. Here's a picture of the entire Expedition 65 crew. From left to right is Dubrov, Shane Kimbrough, Megan MacArthur, Thomas Pesquet, Aki Hoshide, who's the current commander of the complex, Oleg Novitsky, and Mark Vande Hei. Dubrov and Novitsky will be quite busy during the month of July with the impending launch of the new Nyoka multipurpose laboratory module in the offing on July 15th from the Baikonur Cosmodrome in Kazakhstan atop a Khrunichev Proton rocket. It will take 8 days in transit for an automated docking to the Earth-facing port of the Russian segment of the International Space Station currently occupied by the Pirs docking compartment, which has been a docking port and spacewalking airlock for Russian-based spacewalks for the past 20 years. Pirs has now been deactivated and will be undocked via a unpiloted ISS Progress 77 cargo ship that is currently docked to Pirs. The undocking of ISS Progress 77 and Pirs scheduled for July 17th, 2 days after the multipurpose laboratory module is launched out of Baikonur. The Progress will use its engines to deorbit and dispose of itself and Pirs to a fiery demise in the Pacific Ocean. Pirs' lifetime aboard the station has come to an end and is being replaced by the huge multipurpose laboratory module that will serve as a science platform as well as a venue for a European robotic arm and an airlock from which spacewalks can be staged in the future. And we're standing by just moments from now for a go for the depressurization of the crew lock.
Your green lights on. What? I'm going to put my lights on. It's good for now. At some point, I'll move forward to open the hatch, but for now it's okay. Okay.
Station Houston, Space to Ground 1, you have a go to start on the crew lock depress cue card at this time.
Copy, Drew. That's in work. All right, Shane, on the UIA, switch the depress pump power to on.
Depress pump power is on.
Okay, wait 10 seconds for a complete startup.
Okay, 10 seconds.
Depress pump manual isolation valve to open.
Okay, depress pump man ISO is open.
Both of you monitor your suit pressure gauge. It stays below 5.5.
Copy. Copy.
And the depressurization of the crew lock is now underway. Once again, this will be in a two-step fashion. First, taking the pressure inside the crew lock, or outermost section of Quest, down to 5 psi. We'll pause for leak checks by the two spacewalkers of their extravehicular mobility units before the depressurization resumes down to vacuum. Once again, answering your questions on the hashtag AskNASA. Maggie on Twitter asking, do astronauts always go out on an EVA or spacewalk in a pair? Do they ever go out by themselves? The answer, they're always in a pair. Only one time in human spaceflight history did 3 astronauts go out on a spacewalk. That was on the maiden launch of the shuttle Endeavour on the STS-49 mission. in which Rick Heeb, Tom Akers, and Pierre Thuot went out to perform a manual grab of the Intelsat satellite that encountered a problem with its retrieval for repairs. But typically, astronauts will conduct spacewalks in pairs because of the volume of work that's required and because of the necessity for safety reasons to make sure that a so-called buddy system is in work to allow the two spacewalkers to have another crew member out there with them to assist in the unlikely event a problem would occur.
Peace 5 and stable. Same for me. Yellow P at 9210, should Peace 5 and stable.
Copy. Thomas and Shane, we've got about 1 psi to get to this, but when the crew lock is at 6.0, both of you can expect an alert tone.
Copy, Mark. Copy.
And Shane, we're waiting for the next action until we get to 5.0 psi.
Mark Vande Hei keeping the two spacewalkers on the other side of the hatch up to speed as the depressurization continues down to 5 psi in the crew lock. And again, at that point, we'll pause to permit systems checks, leak checks of the two spacewalkers' suits to take place before resuming the depressurization of the crew lock down to vacuum. Here in the flight control room at Mission Control in Houston, the Orbit 2 team of flight controllers has now taken their positions on console to execute today's spacewalk. Today's team is led by Flight Director Pooja Jesrani at the bottom of your screen. To her right in the white jacket is the ground IV or spacewalk communicator Jenny Sidey, Canadian Space Agency astronaut. She'll be talking directly to the spacewalkers during the course of their excursion outside of the International Space Station. And to her right is veteran astronaut and spacewalker Drew Feustel, who is guiding the spacewalkers through this portion of the pre-spacewalk preparations. He will also be communicating when required to Megan MacArthur and Mark Vande Hei inside the International Space Station, while Thomas Pesquet and Shane Kimbrough are conducting their work outside.
Hold for a few seconds. Follow displayed instructions and let me know when you have leak check complete.
Copy, Mark, can work. Copy.
And on console in the back row here in Mission Control is the lead spacewalk officer, Keith Johnson, veteran spacewalk officer who has presided over all of the spacewalks associated with the ISS solar array activity, these rollout solar arrays, and all of the procedures associated with this activity. He will be talking to his backroom engineers as they work their way through the procedures checklists, and when required, make amendments to the timeline through Flight Director Pooja Jesrani.
Check complete for EV1. Complete EVQ.
Copy. Leak check complete, EV1 and EV2. Both of you confirm your O2 actuators are EVA.
Forward. All right, EVA. I'm an EVA for EV2.
Copy. EVA for EV2. Shane, switch the depress pump manual isolation valve to open and expect an alert tone.
And ISO is open.
The emergency MPV is now open, and on your DCMs, monitor the seat pressure gauge stays less than 5.5. Our next trigger will be when you get to 2.0 PSI.
10 mark. Copy.
We're in a brief handover between satellites on our tracking and data relay satellite system, about to regain our downlink video from the station, and there it is. The depressurization of the crew lock section of Quest has resumed after a brief pause. Good leak checks on the crew's spacesuits. Everything in order for the start of today's spacewalk coming up in just a few minutes.
P5 and stable EV1.
Copy.
P5 for EV2.
Once again, if you're just joining us on NASA television and on the web, we are moments away from the start of the third spacewalk in the past 9 days by Shane Kimbrough and Thomas Pesquet of the European Space Agency. Today's spacewalk to remove from flight support equipment the second of the two ISS rollout solar arrays, brand new solar arrays, designed to augment the power capability of the International Space Station. This particular array to be moved over to the far port truss, the P6 truss, on the left side of the International Space Station, to be installed on a mounting bracket and then unfolded and unfurled for the 4B power channel, joining a similar array that was installed this past Sunday and unfolded for the 2B power channel. That array is up and running and generating great electrical capability.
On 2, Timo. 2.0 right now.
I copied your reading 2.0. All right, with the reading of 2.0, Shane, you can switch the depress pump manual isolation valve to closed.
All right, so it's closed.
On the UIA, Shane, switch the depress pump power to off.
Depress pump power is off.
Copy off. Go ahead and report your initial tether configuration for egress.
All right. I'll start from my left steering extender. I have my red hook closed and locked, black on black. Goes to my red reel, which is unlocked. The yellow hook goes to my medium workstation. On my red reel, I have Shane's yellow hook closed, locked, black on black. Goes to his red reel that I see unlocked, and Shane, you can pick it up from there because I don't really see it after that. I have my right waist tether on the airlock waist tether, and I see 1, 2, 3, 4 hooks are locked. That's good config, and then my left safety tether, red, there it is. I see it, yeah. Red hook is on my left E-ring extender, closed and locked.
Thank you. Okay, I see that as a safe config. If the ground wants to double check something, they can give us a call. I'm going to progress. So when the crew lock PDT is approximately 0, you both can expect an alert tone.
Copy.
And when we get to a half PSI on the PCS here, I'll call the ground to confirm that they agree that we've gotten to less than half PSI, and then we'll give you the next steps.
Good luck.
Ground copies and concurs, and that's a good tether config.
Hi, Jenny, and hi, GE18.
The pressure inside the crew lock across the hatch from where you're looking right now, where Mark Vandehei is, the two spacewalkers are jammed inside the crew lock, side by side, standing by for the crew lock to go down to vacuum, at which point they'll be allowed to open the hatch. First, the outer thermal cover will pop open. Following that, the hatch will be open. The crew members will place their suits on internal battery power to mark the official start of today's spacewalk. The new ISS rollout solar arrays that are in the process of being installed on the station today, the second of 6 such arrays, are the precursors to a derivative of those that will be used for the Gateway program. The Gateway program developing an outpost that will orbit the moon to provide support for the long-term human return to the lunar surface, as well as a staging point for deep space exploration. You can see the difference in the current ISS, the so-called legacy or heritage ISS solar array wings for the 8 power channels on the International Space Station. The smaller rollout solar arrays that are in the process of being installed on the station to increase the power capability of the complex by some 120 kilowatts when they're all installed, all 6 of them. And the PPE, or power and propulsion element, solar array wings or rollout solar arrays that will be developed from the technology being gleaned from the current set of solar arrays being installed on the station for the Gateway program. Elements will be about 60 feet long by 32 feet wide, weighing about 950 pounds of mass. So today's activities and 4 additional solar arrays to be installed on the station after today will be the forerunner for the types of power generation systems that will be used for the Gateway program around the moon. We are approaching 1 pound of pressure per square inch in the crew lock section of Quest. The spacewalking team in mission control reporting 2 good suits for Pesquet and Kimbrough as they stand by for the crew lock to go down to vacuum.
Airlock Houston on 1. We're tracking 6 to 8 more minutes of depress.
Copy, Jimmy.
Pressure in the crew lock steadily creeping down to 0. A view through the porthole at the hatchway between the equipment lock and the crew lock. You can see movement by one of the 2 spacewalkers through the window. The International Space Station is currently flying 255 statute miles over Newfoundland, about to begin a northwest to southeasterly track across the North Atlantic in an orbit inclined 51.6 degrees to either side of the equator. Just a few more minutes before we reach vacuum. Everything proceeding on time, on track for the start of today's spacewalk, the third in the past 9 days in support of the deployment and unfolding and unfurling of the first two ISS rollout solar arrays. Almost at vacuum. Megan MacArthur in the field of view there momentarily. She'll be driving the Canadarm2 robotic arm today with Thomas Pesquet at the end of the arm, who will be hauling the ISS rollout solar array from the flight support structure that it is currently attached to over to the Port 6 truss work site. He'll then hand it off to Shane Kimbrough. He'll get out of a foot restraint at the end of the arm and receive a handoff back from Kimbrough of the array as the two work in tandem to install it on a mounting bracket on the so-called mod kit previously installed on a past spacewalk as one of the key moments in today's activities to install and unfurl this second of 6 planned rollout solar arrays.
Gauge on the EV hatch, and I'm going to take the hatch to open. And can you screw over to your right a little bit? Alright, the hatch is unlatched. LED's open. Thanks.
Copy, the hatch is open. Is it stowed as well, Thomas?
Please open and stowed.
With that, I'm turning the emergency MPV to closed.
These lights outside, Shane.
Okay, emergency MPV.
The hatch is open to the crew lock section of Quest.
Assisting you with today. Good luck. And Jenny, we're looking forward to working with you as well. Over to you.
Call for you.
Thank you, Mark and Megan. Well done. I am ready to pick up in post depress. Thomas and Shane, switch power to BAT. Stagger your switch throws. Expect warning tones.
One's in BAT. ED2 and BAT.
Copy. Check your display switches functional.
The switch is functional EV1. Functional EV2.
Copy. Display switch is functional. On the UIA, switch power EV1 and 2 off OFF and check power EV1 and 2 LEDs. All 4 are off OFF.
Our EV1 and 2 switches are off. LEDs are off.
Disconnect your SCUs from your DCMs. Install your DCM covers and stow your SCUs in their pouches.
Good work. Work. SU still in the cover for EV1. Same for EV2.
Copy. Check depress pump man ISO valve closed.
Man ISO valve is closed.
Temperature control valve max hot.
This is Mission Control Houston. Kimbrough and Pesquet have placed their suits on battery power at 6:52 a.m. Central Time, 7:52 a.m. Eastern Time, marking the start of today's spacewalk, the 241st spacewalk in support of space station assembly maintenance and upgrades. Again, our spacewalk now officially underway as Pesquet and Kimbrough have placed their suits on battery power, 6:52 a.m. Central Time, 7:52 a.m. Eastern Time.
We copy, Shane. That's expected in the depress. We're not concerned with the suit pressure that you just read us.
Okay, great. Okay, so we've got temperature control valves in max hot for EV1. And max hot EV2.
Copy. Temperature control valves in max hot. Switch water on.
Water is on EV1. Water on EV2.
Check DCM blank and bite off.
And blank, bike off EV1. DCM blank, bite off EV2.
Temp control valve set as desired.
Spacewalk communicator Jenny Seide, a Canadian Space Agency astronaut here in Mission Control, running through the post-battery power steps with the crew. The hatch is opened to the Quest airlock.
Pressure gauge and report it.
Waiting for the outer thermal cover to be open. Pesquet will be first out. He's wearing the suit with the red stripes as EV1 or extravehicular crew member number 1. The helmet cam number will be 20 for Pesquet.
Copy.
Shane Kimbrough's helmet camera number is 22. Kimbrough wearing the unmarked suit.
Okay, and with that, Thomas, you can open the hatch thermal cover, stow the hook on the stiffener tether point, and cinch strap until snug. We're expecting 6 lines visible.
Mark. It's cinched, 6 lines, and I'm opening the thermal cover.
Copy, 6 lines.
Jenny, we'll go for egress.
Affirm, you can egress the airlock. Thomas, you're taking crew lock bag 1 with you. Verify forward hat pitch pin engaged.
All right, so egressing yellow. Get ready for crew load bag 1. Red on it, you can let go of the other red chain. Okay, it works. Okay, it's done. Good.
Our first view of the Quest airlock, about to celebrate the 20th anniversary of its use, having been installed on a mission of the shuttle Atlantis to the International Space Station in July of 2001 on the STS-104 mission. Thomas Pesquet first out, beginning the 5th spacewalk in his career.
Hey. Got crew load bag 1, and Jenny, if you agree, I'll start checking the last load alligating strap on the 6 tethers. It's good for both, so you know, right?
Copy, Thomas. You can agree. You can store your crew lock bag on your BRT. We'll also have you turn on your HECA, and then you're correct. You'll move on to inspecting the load alleviating straps on the tethers.
So that is done, Jenny, and my HECA is on. I'm gonna put my green hook on my yellow hook on the green reel. Black on black. You agree?
Standby 1, Thomas. Have you turned on your HECA?
Yes, Jenny, I've turned on my HECA.
Okay, and you inspected both load alleviating straps?
Yes, I've reported this. This is done for both, and my green hook is on my yellow hook is on my green reel, locked, black on black.
Okay, copy. You can attach the forward safety tether green hook to your red reel.
It works.
Once Pesquet has completed the configuration of his tethers at the vicinity of the hatchway to the Quest airlock, Shane Kimbrough will be next out.
Both reels are unlocked, and the yellow hook is locked.
Copy, Thomas. That's a good config. You can attach Shane's yellow hook to the green reel on the aft external D-ring.
Yeah, that's the work, Jenny. And Shane's yellow hook is now attached to the aft green reel. The hook is closed and locked black on black. The green reel is unlocked.
Copy. Attach Shane's green hook to his red reel.
Shane's green hook is now attached to his red reel, and the reel is unlocked.
We're tracking a good tether config with good checks, so you can give Shane a go to release his waist tether from the airlock waist tether and egress the airlock.
Okay. And Shane, I'll go to egress the airlock. Now you're in a good config. Okay, waist tether is released. My hacker is on. I'll start coming out.
Copy, Shane.
Crew like that 2 on my ret.
Copy.
All right, Tomas, see you there? Yep, looking good. Get out of your way. All right, let me get my BRT up.
Close-up view of Thomas Pesquet on the left, Shane Kimbrough emerging from the Quest airlock on your right. The International Space Station flying 255 miles over Chad in Central Africa, moving from northwest to southeast.
All right, just got a crew light tag on my BRT and on the BRT ret. So that's small. All right. Thermal cover, you ready for that?
Ready. When you close the thermal cover, I have steps for you if it does not stay closed.
Hold on, I'm getting, okay, now my waist tether's clear. It's, well, looks like it's staying closed for now. Don't breathe. Hey, Jenny, it's staying, looks like it's staying close.
Copy.
You want us to put the wire tie or not?
To be safe, we are going to put the wire tie on anyway. So the wire tie, which you pre-staged, you can loop around the thermal cover soft goods handle. And keep in mind, we don't have helmet cams until we do our buddy checks.
Yep. He's working on this. Okay, that's complete. Complete.
Copy. We're ready for buddy checks
Okay,
when
buddy
you are.
checks. Shane, I see you have 2 green LEDs. It's on. You got 1, 2, 3 tabs up, 1 on your VRT, 2 on your workstation. Your 2 safer handles are down, and your tether is in a good config. You get your bag on your BRT, the red. Good. Okay, Tomas, I see you have 2 green LEDs. Your lights are on. Your BRT tab is up. 1, 2, many workstation tabs are up. Left safer handle's down. I can't see your right one. And right safer handle is down. And I see your tether behind you coming out your right side. That looks good, and I have a dry hat for you. Okay. I should, my tether starts from my left, right? And it goes across to my right. Yes, I see that now, yep. Okay. Going to your right side, yep. Sounds good. And dry hat for EV1.
Copy. That is a good config. Well done. We will start with Shane translating out to the FSE tower handrail. Thomas, you can follow behind.
All right, Shane, let me get out of the way. So as soon as you pick up your local, you're good. All right, come out. See you up there. See you up there. And
having conducted initial so-called buddy checks, making sure each other's suits are in the right configuration, Pesquet and Kimbrough now have completed the first phase of their post-egress activities. Pesquet about to make his way now over to the flight support equipment that houses the second of the ISS rollout solar arrays. He will be joined at the Port 6 work site by Shane Kimbrough a short time from now. The first order of business for Pesquet will be to use a pistol grip tool to release 2 bolts, boom end launch restraint bolts, in the first phase of ongoing activity that will ultimately result in the release of the array from its flight support equipment. That flight support equipment will be robotically transferred back to the trunk of the SpaceX cargo Dragon vehicle to be later disposed of. SpaceX, that cargo vehicle to be undocked from the International Space Station on July 6th for an entry and splashdown in the Atlantic Ocean on July 7th, returning scientific payloads and other cargo from the station. Before splashdown, the trunk of Dragon will be jettisoned, and along with it, the flight support equipment that carried up these first 2 solar arrays.
No sudden movements, quick stops, quick grabs on the FSE. Wait until FSE motion dampens out before imparting any loads. While working on the FSE, you must not simultaneously impart loads, and do not contact IROSA blankets. These solar cells are fragile.
We copy all journey, no touch, recovery couplings, grapple fixture, bus cable, and gentle on the FSE. 62 copies.
Affirm.
One of the reels is not retracting very well. Yeah. So like one of mine. Yeah, you're getting close to the end. Yeah. Of the tether. We stop here and do it, or wait till we get up there? You're right there, you know? I'm just going to stop here. Yeah. Makes sense. Yeah.
Ground copies.
Okay, I cycled it. It seems to be working better now. Nice work.
Copy, Shane.
Okay, I see EV1's anchor hook closed and locked. EV2's closed and locked, and EV2's is on 52, I think is the last two.
It's a good number.
EV1's is on 51.
Okay, copy. That's a good config.
That's how I'm going to head out.
Concur. Shane, you can continue translating. You're translating outboard to P6, and it's Thomas who's translating to the FSC tower handrail.
Yep, copy. Well, keep an eye on
Pesquet and Kimbrough now making their way to their respective work sites. Pesquet to the flight support equipment housing the second of the first two ISS rollout solar arrays. Kimbrough making his way to the far port truss side of the International Space Station to await Pesquet's arrival with that array. The International Space Station about to cross the southeastern coast of Africa, moving to the south of Madagascar and over the Indian Ocean. We are in a handover between satellites on our tracking and data relay satellite system. We'll regain our downlink capability from the station momentarily.
We're back with you after a handover. Shane, I have warnings and cautions for you when ready.
Go ahead, Jenny.
Sharp as edge hazards on the MT rail attachment lug near the 2 Bravo IEA inboard radiator corner, and the pit pins on the ticker and the sticker do not meet EVA kick loads. As you continue to translate outboard, avoid contact with the deployed and stowed radiators, and the battery adapter plate cables on the IEA are a potential snag.
V2 copies all.
Cautionary instructions for Shane Kimbrough from Spacewalk communicator Jenny Seide here in Mission Control. Once Pesquet is at the flight support equipment, he will use a pistol grip tool to release a pair of bolts, boom end launch restraint bolts. The first in a series of such usage of the pistol grip tool throughout the course of the spacewalk that will free up the array and enable Pesquet to transport it while affixed to a foot restraint at the end of the Canadarm2 robotic arm. He will be driven to the worksite to join Kimbrough. The robotics operator inside the station today is NASA astronaut Megan MacArthur.
Copy. You can continue to translate outboard to P6. I have a green hook handrail number when you're ready.
Yeah, just a minute on that, Jenny.
You're looking for handrail 5388, Shane.
Okay, copy. And Jenny, I'm on the SSC. I'm making my way to the tower.
Copy. Good words, Thomas. You'll be stowing the crew lock bag there.
Copy.
A good view of the second of the ISS rollout solar arrays. There will be 6 such arrays attached and unfurled at the International Space Station on the port and starboard trusses of the station for 6 of the 8 power channels of the complex. The 6 power channels to be augmented with 20 kilowatts of power from each array, specifically selected because of the power demand for various systems that run on those 6 power channels.
All right, Jenny, I'm at my green hook location, so give me a minute to set that up.
Copy, Shane.
Okay, green hook on 5388.
Copy, Shane. You can translate to the mod kit left lower struts.
Shane Kimbrough, just about at the work site at the port 6 truss of the station, at the mounting bracket or so-called mod kit previously installed on a past EVA. He'll be stowing a crew lock bag with various equipment and tools that he and Pesquet will be using for the installation of the ISS rollout solar array at the opposite side of the truss to which the 2B rollout solar array was installed this past Sunday.
How you doing, Tomo? Doing good, Shane. I'm been working on the crew load bag. Done in a minute.
Shane, I have a caution for you when ready.
Go ahead.
No sudden movements on the mass canister or mod kit. Translate slowly and avoid cyclic loading.
Then you have the crew load bag on NRL 0013.
Copy. That's a good config, Thomas. Next, we'll be releasing R1 and R2, so you can translate to the zenith boom end of IROSA.
R1 and R2 on the zenith side.
R1 and R2, referred to by Spacewalk communicator Jenny Seide, are the boom end launch restraint bolts. The first of 4 bolts. There will be 2 additional bolts for the outer deployment restraints on the IROSA or ISS rollout solar array. A good shot of Pesquet from a truss camera on the station as he begins work with a pistol grip tool to free up the array that he will transport over to the far port end of the truss or backbone of the station to hand off to Shane Kimbrough in this choreography that is expected to result in the installation of the array on the mounting bracket or mod kit for the 4B power channel of the Port 6 truss of the International Space Station, that will be then unfolded and unfurled to its full length of about 63 feet.
Jenny, I'm at the IAA. I'm going to barely leave my safety tether here.
Copy, Shane. Just give us words on how you do that. This is the rich man you told us about, correct?
Correct on 5359.
Copy 5359 for your safety tether fair lead, Shane.
Jenny, I'm in position to drive R1 and R2.
Copy. You ready for settings?
And we calibrate my PDE, and I'll be ready.
Copy. Sounds good. Shane, you'll be stowing the crew lock bag on the left lower strut handrail closest to the mounting bracket. That's the lower handrail stanchion.
My fair lead is in.
Copy, Shane.
Jenny, I'm ready for PG settings.
Alpha 4, counter 2.
Copy Alpha 4. Counter.
Good read back. Again, counter 2. You will be releasing R1 and R2 10 to 13 turns each. The bolts will spring out when fully released, and it's about 3 minutes until our first eclipse.
Yeah, to Cal again, I think I bumped it too up. Can you give me those settings, number of turns one more time, just to be sure?
No problem. Alpha 4, counter 2, 10 to 13 turns.
10 to 13 turns, and I'm working on R1. Jenny, I have 12 turns, and the bolt is popped out.
Copy. 12 turns, the bolt popped out. Was that R1 or 2?
R1.
Pesquet using a pistol grip tool at the 34-minute mark into today's spacewalk by Pesquet and Kimbrough. Pesquet with the red stripes says EV1, or extravehicular crew member number 1, using this device to release a pair of bolts, the first of a series of bolts that will free up the roll-out solar array so it can be removed from its flight support equipment to be transported by Pesquet at the end of the station's robotic arm over to join Shane Kimbrough, who is now at the port 6 or far port truss at the end of the backbone of the station on the left side of the station.
The scoop will be facing inboard.
Working on my deconfigure from the crew. And you have 11.5 turns, both fully popped out on R2.
Copy, 11.5 turns on R2. The bolt is fully popped out. You can rotate both boom deployment system rollers to the deployed position.
It works. How you doing, Shane? Good. I'm setting up, getting the scoop out right now. Set up.
For both of you this time, I'll need us to turn on our HECAs one more time and report whether you have a green light, please.
Is on, green light.
Copy, 3P2.
All one's fully rotated, and Jenny, mine is on with a green light. On and off and on.
Affirm, Thomas, let's cycle it.
Off. And he's back on with a green LED.
Copy, thanks, Thomas. Thomas, with the boom deployment system rollers deployed, we can move on to R3 and R4.
I'm still working on R2, Jenny. It's slow. It goes slow.
Copy.
Jenny, the installed still attached to the crew like that.
Copy, Shane. You cut out a bit there. I understand the scoop is installed and it's still attached to the crew lock bag. Okay, copy. Shane, your next task is to route the wire cables on the right side of the mod kit. You can head to the cable bag now. Let me know if you need additional words on routing.
Right side cable. Jenny, I'm having my PGT and I'll be ready for settings on R3 and R4.
Copy, Thomas. As a reminder,
I will start with R4.
You're going to start with R4, understood, and these are the bolts. As a reminder that we will be releasing 245 turns. So we'll verify the PGT turn count is 0 before we start, and if you call out the turns at an interval of your choosing, we'll follow along with you.
Yep, that sounds good.
R3 and R4 are a pair of outer deployment restraint bolts. The second pair of bolts that Pesquet is releasing to enable the solar array to be removed from its flight support equipment.
So 3, notice 3, that's 0. Now go ahead and drag R4.
Copy.
turns now. And 30. How you doing, Shane?
Good. I'm getting your cables here. Driving the.
So that's 3 turns.
Right on your right cables.
Copy.
Side.
Turns. Under turns.
Copy.
Under then 30 turns. Under then 50. Underneath. Under turns.
Nice.
Under 35. 40. Under 45 turns on R4, Jenny.
Copy. 245 turns on R4. Now we'll check that the tie-down bolt protrudes from the base of the IROSA root beam. Should be just on the other side of the handrail from you.
I can see that very clearly, Jenny. It protrudes out very nicely.
Excellent. Well done. We'll move on to R3. We have new settings for you.
The first 2 bolts have been released, holding the array in place on the flight support structure. Pesquet now will press ahead to release 2 more bolts, the outer deployment restraint bolts, with his pistol grip tool. We are now 44 minutes into the spacewalk, the crew right on the timeline. For those watching NASA television and who have been following the launch of a sounding rocket from the Wallops Flight Facility, Virginia, on the media channel, that activity was successfully completed a few minutes ago, and so we are now simulcasting on both the public and media channels for the remainder of today's spacewalk.
Turns. Five turns. The turns. How are those cables treating you, Shane?
I just got the first power tie down. Still working.
140 turns. Jenny, are you getting our headcap video now?
We are for both crews, thanks.
Oh, thanks. I've been saying 5 turns.
To me. Power tie, it's not far enough out, Jenny.
Say your last, Shane.
I'm going to have to reposition this wire tie. It's not far enough out.
All right, we copy.
One on the red.
No rushing, but plenty of time. 15 turns. $30. 35. 40. 35 turns on all 3, Jenny. I see the indicator popped up. Actually, it did in 210 and 220 turns, if that's data that you're interested in.
Copy, that's good for us to know, but we also copy 245 turns on the bolt. Thank you, Tomas. You can stow your PGT and translate back to the tower handrail. You'll be stowing your PGT and retrieving Shane's.
Copy.
Shane, after you're finished placing that last wire tie, you'll be pre-staging the adjustable equipment tethers on the upper strut and the lower strut handrails for when we install IROSA.
I'm getting my PGT as a red to power handrail. I'm going to go ahead and retrieve Shane's green PGT from my crew lock bag.
Good words, Thomas.
Hey, Jimmy, I got an adjustable on the upper handrail. It's a large, small adjustable on the upper handrail on the lower struts.
Copy, Shane. That is a good config. You can head back to the cable bag and pick up the left wire cables. We'll be doing the same thing on the left side of the mod kit, but keep in mind when you pre-stage the tethers, you'll probably need to pick up tethers from the crew lock bag.
Copy that. Thank you. Under. Okay, I'm going to head back and get the white kit.
Copy, Shane.
This is Mission Control Houston, 55 minutes into today's spacewalk. Thomas Pesquet, using a pistol grip tool, has released 4 bolts, restraint bolts used to maintain the ISS rollout solar array in a safe configuration on flight support equipment it launched on in the trunk of the cargo Dragon vehicle that arrived at the station a few weeks ago.
We're going to verify that R5 is released.
Okay. So that's on the other side, closer to pull on, don't translate nadir. R5, Jenny, that's good with you.
That sounds good to me, and good words. R5 is next to Stanchion Bravo, so Zenith inboard by the POA.
The R5 bolt being referred to by Spacewalk communicator Jenny Seide is a hinge restraint for the solar array on its flight support structure. Next up for Pesquet would be the release of anti-rotation devices. This was a feature installed for launch to maintain structural integrity for the array on the flight support equipment.
Major better than the okay. Can see R5. Looks like it's fully pumped out.
Copy, and it should be fully sprung out if it's released.
There's no marking though, but it looks like it is protruding a lot from the base. I think it's a good release. I don't think I can get my hand there though.
Copy, Thomas. Can you use the socket of the PGT just to check that it is fully sprung out, please?
That's what I'm thinking, but is the PGT right size?
Jenny, I have the white cables. I'm at the lower struts.
Copy, Shane. And Thomas, you do have the correct socket.
Yeah, Jenny, I can push it in and out with the sockets. It's fully released.
Copy. That sounds great to us. You can stow your PGT, and we'll move on to the anti-rotation devices. So that has you starting at C11, which is nadir and outboard.
Copy. Making my way back to C11.
Good words.
Jenny, I see 11.
Copy, Thomas. You can attach your adjustable equipment tether to the ARD tether point.
Good luck, Jenny.
All right, Jenny, same story here. I'll have to read.
Copy, Shane.
This is Mission Control Houston, 1 hour into today's spacewalk by Thomas Pesquet of the European Space Agency and Shane Kimbrough of NASA, the third spacewalk this duo has conducted in the past 9 days.
Copy, Thomas. We know that was a
Pesquet is in the process of working to release a series of bolts holding the ISS rollout solar array for the 4B power channel on the International Space Station's P6 truss from its flight support equipment. Shane Kimbrough is over at the P6 worksite as he is stowing equipment and preparing to route a series of cables that ultimately will be used to hook the array up to the electronics assembly for the P6 truss integrated electronics system.
Good luck on the cables, Shane. Yeah, getting there.
The spacewalk began at 6:52 a.m. Central Time, 7:52 a.m. Eastern Time, when Pesquet and Kimbrough placed their suits on battery power in the Quest airlock. They moved outside, configured their tools and tethers, and then made their way to their respective work sites to begin the process of removing this array from its flight support equipment that it was launched on a few weeks ago on the SpaceX Cargo Dragon vehicle. The array will be moved by Pesquet while he is affixed in a foot restraint at the end of the Canadarm2 robotic arm over to the P6 worksite, the installation worksite, where Kimbrough is waiting for him. He will be driven on that arm by astronaut Megan MacArthur, operating the arm from a robotics workstation inside the International Space Station. Here in the flight control room, Flight Director Pooja Jasrani is watching over the work being conducted by the crew, assisted by spacewalk communicator Jenny Sidey, the astronaut from the Canadian Space Agency.
Fit. And turns on the stop block bolt.
Copy. That was 7 turns, Thomas.
That was 10 turns, Jenny.
Copy. 10 turns. Thank you, Thomas. You can release the ARD, and then I have new settings to drive that stop block bolt back to torque.
Okay.
Jenny, tie down's complete. I'm working on the...
Copy, Shane.
Once Pesquet has removed this anti-rotation device, another launch restraint mechanism holding the array in place on the flight support equipment, he will then begin to break torque on the final bolts holding the array in place. There's a view of the Canadarm2 robotic arm. A portable foot restraint will be affixed to the end of the arm by Pesquet. He will then mount that foot restraint to move the freed solar array over to the P6 worksite where Kimbrough is waiting.
Okay. ARD is released on C11.
Copy, Thomas. I have settings when you're ready.
Okay, just 1 second. I'm ready, Jane.
Bravo 1, clockwise 2.
1. Flight 2 is set.
Good words. You'll be driving the stop block bolt to torque.
Driving the stop block bolt. To torque, sorry. Mark.
Getting the adjustables are in place on the left.
Copy, Shane. Next up for you is to pre-stage a wire tie and tether on the middle soft capture feature. When you do this, we want it to be fully slack so that the soft capture feature is able to engage initially when we're at the mod kit.
We have a 11.9 torque, green light, 3.5 turns. It's just like last time, the stop block rides up on the base of C11, so it looks snug to me.
Okay, copy, Thomas. That's fine with us. You've got a green light, 11.9 on the torque. That was 8.5 turns. You can stow your PGT.
So that was 3.5, 3.5.
Copy, 3.5. Thank you. You can stow your PGT and translate to Charlie 12.
Pesquet is moving smartly along in the release of a variety of different bolts and launch restraints holding the array in place on this flight support equipment. He is in the process of breaking torque on the final bolts holding the IROSA or the ISS rollout solar array in place. Meantime, Shane Kimbrough is pre-positioning equipment along the mast canister at the very base of the P6 solar array, where a mod kit or mounting bracket is set up and was installed on a prior EVA, to which this second solar array will be attached on the opposite side of where the 2B rollout solar array was attached during Sunday's Spacewalk.
Jenny, I'm in position, Charlie 12, and I'm ready for setting.
Copy. Confirm that you've attached your adjustable to the ARD tether point.
No, not yet, Jenny. It's a good catch. Not a better position.
We have about 1 minute and 30 seconds till sunrise.
Thanks. Jenny, I have the other end of my AET on this ARD tether point, and I am ready for setting.
Good words, Thomas. Bravo 3, counter 2.
Bravo 3, counter 2.
Release
Bravo
the
3. All right, Jenny.
Release the stop block bolt, 10 turns only.
Turns on the stop block.
This is Mission Control continuing to take questions in on hashtag AskNASA from our viewers. Twitter user asks, how do the astronauts get their tools out of the tool bag while spacewalking, as they might drift away in space? All these tools are in a device called a tool caddy, which is essentially a tool bag that they carry along with them and which is double tethered to various positions along the paths of their movements on the outside of the International Space Station. They simply reach into the bag, pull out a tool, make sure it's securely tethered in place so it doesn't float away, and then use those tools as necessary.
It can deploy when we need it.
Kate on Twitter asks, do all the astronauts train for solar array EVAs or spacewalks like Thomas and Shane are conducting? The answer, not exactly. All crews flying on the International Space Station have crew members who are trained in generic tasks, contingency tasks, in the event certain critical hardware is broken and must be replaced, and then mission-specific tasks, such as the ones we're watching for this solar array work, they are specifically trained for by crew members on the assumption that they're going to be aboard the International Space Station at the time that hardware arrives in orbit.
Ready to head back to Thomas?
Shane, you can verify that the strut MLI is clear for IROSA install, and then we'll have you release your fare lead, pick up your green hook, and head back inboard.
Okay, the MLI is bringing all. Whatever. That's it. Okay. Second ALD is retrieved on my AET, Jenny.
Copy, Thomas. Let me know when you're ready for settings to drive the stop block bolt to torque.
I'm ready.
Bravo 1, clockwise 2.
Bravo 1, clockwise 2. Then yeah, 11.9 on the torque, good green light, and 4.2 turns.
Copy, Thomas. 11.9 torque, green light, 4.2 on the turns. The stop block bolt is driven to torque. You can stow your PGT.
PGT is stowed, and I'm heading back to the crew lock bag.
Affirm. When you are at...
Thomas.
Go ahead, Shane.
Just job nicely done.
Agreed. Nicely done, Thomas. When you're at the crew lock bag, you can stow the adjustable equipment tether with the ARDs, retrieve the scoop with the long-duration tie-down tether, and we'll also be doing a socket swap on the green PGT.
The anti-rotation devices have now been released by Pesquet. Next up, braking torque on the final bolts holding the rollout solar array on the flight support equipment on the truss of the station. There's a good view of Thomas Pesquet at the flight support equipment. At the top of the screen is the second of the rollout solar arrays to be installed on the P6 truss of the International Space Station. This one for the 4B power channel, matching the 2B channel array that was installed during the last spacewalk this past Sunday. Just before we lost our signal during a handover between satellites on the Tracking and Data Relay satellite system, the International Space Station flying into an orbital sunrise, about to cross the coastline at the border between California and Oregon, moving from southwest to northeast, soon to cross the Pacific Northwest.
Back to the bag. I'm retrieving the scoop.
Copy, Thomas. We're back with you after a handover. I copy that you are retrieving the scoop from the crew lock bag. Can you confirm whether you stowed the adjustable?
Yes, correct. Stowed and then retrieved.
Copy all.
The rollout solar array technology being installed on the space station to augment the power capability of the complex is going to be used for the Gateway program, the Gateway being an outpost that will be developed and orbited to fly, to orbit the moon, to provide support for the human return to the lunar surface and a staging point for deep space exploration. It's a critical component of the Artemis program. You can see in this graphic the current legacy or heritage ISS solar array wings and their vast size, the comparative size of the rollouts solar arrays being installed on the International Space Station to provide an additional 120 kilowatts of power for station systems, payloads, and new modules to be launched to the complex. And on the far right, what the power and propulsion element for Gateway, that solar array wing, is going to look like for the hardware that will be launched to orbit the moon, serving as a way station for deep space exploration.
Good words.
Yeah, I have my green hooks coming in.
Copy, Shane. You'll be translating to the FSE grapple tower. Just coordinate with Thomas when moving on the FSE.
"255 miles over Idaho, Thomas Pesquet is at the flight support equipment. He'll be breaking torque on the final set of bolts holding the solar array that you see at the top of your screen to that structure.
Et de 12-inch 760 on the socket carry, j'ai click pour test. Now I'm retrieving the 5/8 12-inch my PD.
Copy. And good pull test on the 7/16 12-inch.
Going tomorrow. Doing good. I'm here ready to come on the FSC whenever you're ready. Oh, okay. No hurry. Your safety tether there. You're at the crew log bag right now? I'm at the crew log bag, working on my packet swap. Should I go on this routing to get it? I didn't copy that, so you're breaking up a little bit. Yeah, which route should I take to get there to not interfere? I think it doesn't really matter. I think my 6-7 is kind of more nadir right now, and I'll go nadir for the fault. So you can go Zenith. Nadir as well. Try to avoid that. And I got a 5/8, 12-inch on my PGT. Good pull test.
Copy, Thomas. We'll now be braking torque on the IROSA FSE bolts, Charlie 12 and Charlie 11. We'll be starting with Charlie 12.
Copy, Charlie 12. Okay, Shane, let me know when you've stopped translating. You're coming nadir? I'm coming nadir. On right now. I'm clear, boot tether. Are you on the FSE? I am. On the Zenith side now.
Shane Kimbrough now joining Pesquet at the flight support equipment to lend a hand as Pesquet is about to work with his pistol grip tool to release a final pair of bolts holding the solar array that you see at the very top of your screen to this flight support equipment. The two arrays, this first pair of arrays, were launched in the trunk of the SpaceX Cargo Dragon vehicle a few weeks ago. This flight support equipment will be robotically detached from its location that you see on the truss and reinstalled in the trunk of Dragon. SpaceX is scheduled to undock the Cargo Dragon vehicle on July 6th and deorbit for a splashdown in the Atlantic Ocean the following day, bringing home scientific experiments and other cargo. The trunk of Dragon will be jettisoned and disposed of with that flight support equipment prior to the re-entry of the Dragon for its parachute-assisted splashdown in the Atlantic Ocean.
Braking torque, and your settings are Bravo 3, counter 2.
Up to half-stone, braking torque, Bravo 3, counter 2.
A-firm.
I'm at the tower, and I'll just hold here. Yep.
And Shane, understand you're holding in position. I'll have big picture words for both of you once Thomas breaks torque on Charlie 12.
Sounds good, Jenny. Got Bravo 3. Is it clockwise 2 or counter 2? Counter 2, correct?
Counter 2.
Okay, Bravo 3, counter 2, Charlie 12. That's the turn.
Good words.
Okay, that's done.
Copy. You can translate to Charlie 11.
11.
Big picture for you both. We are more or less on timeline. PET 1 hour 25 minutes and our limiting consumable is 7 hour, 10 minute on EV2 MEDOX.
Copy, Jenny.
At this point, Shane, we're going to have you hold position. I have a couple of steps for you, but primarily we will be waiting to release Charlie 11 once Thomas has configured the arm. In the meantime, I'll take a glove inspection and a HAP check from you.
EV1's gloves look good, no change, dry HAP.
Copy.
Ready, I'm in position for Charlie 11.
Copy. Same settings, Bravo 3, counter 2, and you'll just be braking torque.
Bravo 3, counter 2. Okay, torque is broken on Charlie 11.
Copy. We'll now be releasing the IROSA FSE bolts. So starting with Charlie 11, so in your current location, we'll be releasing it 27 turns only, which is just halfway, so not fully releasing the bolts. And your settings are Bravo 3, counter 3.
Bravo 3, counter 3, I'll put down my BRT for charge day.
Copy. Shane, you can retrieve the square scoop from the crew lock bag and stow it on your mini workstation, and I'll also get a confirmation of a green light on your HECA when you're ready.
This is Mission Control Houston. We're approaching the 1 hour, 30-minute mark into today's spacewalk by Pesquet and Kimbrough. The crew just about on the timeline. Pesquet is releasing the last of the bolts holding the IROSA or ISS rollout solar array in place on the flight support equipment, being assisted by Shane Kimbrough. You can see him using a pistol grip tool. Once these bolts are released, Pesquet then will set up a portable foot restraint at the end of the Canadarm2 robotic arm that he will plant his feet in for a ride over to the P6 truss while he holds the array for a handoff to Kimbrough in the first phase of the actual installation process on a mounting bracket at the base of the mast canister at the base of the P6 truss structure.
You can stow your PGT and translate to Charlie 12.
The EV2 has a green light on the HECA.
Copy, Shane. And Shane, we're also going to take a power cycle on the HECA as well.
You want to get the scoop, you said?
A-firm, you're retrieving the scoop and stowing it on your mini workstation.
That's it.
Jetty, I'm ready for settings on Charlie 12.
Bravo 3, counter 3.
Bravo 3, counter 3.
A-firm, and you'll be releasing Charlie 12, 51 to 54 bolts. The bolt will spring out when fully released.
Charlie 12, 1 to 55 turns, 54 turns, sorry.
A-firm.
Me for EV2, power cycle my echo, and I'm going to get speed long duration tight on tether as well. Is that good?
Copy, Shane. And Shane, that's right. You will be retrieving a long duration tight on tether as well. Good catch.
Okay, Jenny, I have to work a little bit on my body position here. So bear with me for a second. And that's all.
Copy.
How you doing, Shane?
Good, I'm just hanging out at the tower here, just
okay,
ready for the next. Up my workstation.
Okay.
Serious turns on the PGT.
I'm sorry, what?
You're getting some serious turns on the PGT.
Didn't copy. I only hear turn on the PGT, Shane. What's your question?
Oh, sorry, I said you're getting a lot of turns on it.
No. I haven't started yet. I'm working on my body position. All right, Jenny, I'm ready for Charlie 12. 4 turns. It's a better position.
Copy, Thomas.
Back. See the IROSA move a little bit up. Turns. One. 39, 40. Both popped out. 45 turns and it's popped out, Jenny.
Copy, C12 is fully released, popped out. Was that 45 turns, Thomas?
Correct. Need a couple more. Now I'm at 50, but the boat is keeping. I think it's a good release. Probably 12.
Okay, understood. You can stow your PGT, and then I'll take a glove inspection and HAP check when ready.
Okay. EV1. And good gloves.
Copy, Thomas. You'll be installing a square scoop on the root beam microsquare near Charlie 12. The handle will be facing nadir.
Copy. Mark.
Thomas Pesquet about to complete the loosening of bolts holding the ISS rollout solar array in place on its flight support equipment.
And the scoop is locked. Pointing nadir on the micro fixture next to Charlie 12 or Charlie 6.
Copy, Thomas. Remove your RET and translate back to the tower handrail. Also, check HAP is dry.
HAP dry. Let's just link back to the tower handrail.
Copy.
Straight foot here, Tom, wait on you.
Yep.
As the International Space Station prepares to cross the northwest coast of Africa on a trajectory from northwest to southeast, Thomas Pesquet has completed the loosening of bolts that has held the IROSA or ISS rollout solar array in place on its flight support equipment. Next up for Pesquet, who's at the bottom of your screen, Shane Kimbrough at the top of your screen, will be for Pesquet to set up a portable foot restraint at the end of the Canadarm2 robotic arm.
Shane, here comes your ring PGT if you want. Actually, let's stand by. Have it. I should need the red. There you go. So here.
Yeah, I got a fence. I'll give you yours back.
Here, my red.
You want me to do a socket swap now or wait?
With this one. Yeah. Ranking up standing, copy that.
Never mind. But I got to drive C1.
head to the arm now.
And Thomas,
Jenny's back.
that's right, Thomas, you can translate to the port CETA cart, and then we will have you give SSRMS a go when you're ready for the published APFR reconfig position.
Okay, copy. Report CETA cart, and I gave Mark and Megan a go when I'm ready.
I'm going to stay here and just to make sure you get cleared with your tether in mind.
Okay.
Before I do anything.
I think it's a good idea.
Let me know when you're clear.
The view from Thomas Pesquet's helmet camera as he is right at that flight support equipment and looking right at the ISS rollout solar array. Moments from now, they'll get the go-ahead to begin work to affix an articulating portable foot restraint to the end of the Canadarm2 robotic arm. Megan MacArthur inside the International Space Station at the controls of the arm from a robotics workstation. She'll be maneuvering the arm into the proper position for Pesquet to install that foot restraint at the end of the arm. He will ultimately ride in the foot restraint at the end of the arm, holding the array that will transport him and the array to the Port 6 truss worksite, where it will be installed on a mounting bracket for its unfolding and unfurling. And the view of Pesquet wearing the suit bearing the red stripes. You can see the Canadarm2 poised to accept the installation of that foot restraint. The next task on Pesquet's list of things to do as he and Kimbrough work in tandem at the 1 hour 43-minute mark into today's spacewalk.
And I will be ready for GCA to the APFR setup position.
Copy. We've got a position that will move 50 centimeters station zenith.
All right, that sounds good, and I'll probably need more, but I'll let you know. Let's start with 50 centimeters, and you can start GCA.
Copy. Start GCA. We're starting motion.
And I see good motion.
See good motion. .25 centimeters to go.
Continue motion.
MacArthur operating the arm, Van de Heye providing visual cues from inside the station as the arm makes its way towards where Pesquet is located. Again, he soon will be installing this articulating portable foot restraint to the end of the arm to serve as a foot platform, a work platform for his transport over to the P6 worksite.
As far as zenith, can you give me, say, 25 or 30, 30 centimeters station aft? I have a great view of the clearance right here.
Copy. 30 centimeters station aft. Starting motion.
I see good motion.
Copy. Good motion. .20 centimeters to go.
Motion.
Brakes are on. Go for APFR reconfig.
Copy. Brakes on. Nice work.
Understand brakes on. Thomas, you can ret to the APFR. You'll release it and install it with a clocking of 12.
Copy, Jenny. That's in work.
Shane, we still have you holding position on the FSE. We don't have any get-ahead steps for you right now, so you can position to release Charlie 11 near stanchion Delta. So that's outboard and nadir, pretty close to where you are now, and we'll just have you hold there.
Copy, Jenny. I'll put over there and
Copy.
Jenny, APSR is out. I've already installed the clocking of 12. Okay, the paddles are out. The color is locked black on black. And I have a good pull and tug test. The clocking of 12, Jenny.
Copy, Thomas. Good install. Verify APFR settings, Papa Papa, Fox 6.
Yeah, Papa Papa, Foxtrot 6, Jenny. These are correct settings.
Copy. You can release your RET, and then I'll talk you through the tether swap.
I have my RET back on me, Jenny.
Copy.
For the tether swap.
Lock your green tether reel and check green hook locked.
Okay, my green tether reel locked. My green hook locked.
Copy. Move yellow hook to SSRMS handrail tether point, and I'll take checks.
The yellow hook on the SSRMS tether point is locked black on black, and the red reel is unlocked.
Copy. Attach green hook to the port CETA cart and unlock your green tether reel.
My green hook is attached to the port CETA cart, and my green reel is unlocked.
Good config. Give SSRMS a go to GCA to the published APFR ingress position.
All right. Mark, I'm bringing myself out of the SSRMS. Let me send the ingress aid first to help. Initially for me. And Mark, Megan, you guys are go. And, go station aft. Sorry, station forward first if you need to, and then station nadir. That'd be nice.
Copy. The published position is station forward 20 centimeters and station nadir 50 centimeters. We'll do those in series if you agree.
That sounds perfect, Mark.
Okay, if you agree, we'll call that start GCA.
Start GCA.
And starting motion.
Good motion, station forward.
Good motion. Less than 10 to go.
Copy.
With the forward motion, now we're going to do the nadir motion, 50 centimeters.
50 centimeters. Sure, sounds good.
Starting motion.
Good motion, station nadir.
15 centimeters to go, 10.
Published.
And correction, we got now 5 centimeters to go. And that's the published position. How does that look, Thomas?
That looks good, maybe. Need 10 more, station forward.
Need 10 more, station forward.
All right.
Starting motion.
That's a good motion.
That's a good motion.
And we can stop motion, that's nice. It's a good position, I'll call that GCA complete.
GCA complete.
Mark Vandehei providing visual cues. Megan MacArthur maneuvering the arm from the robotics workstation inside the International Space Station. Thomas Pesquet at the arm, ready to plant his feet in the portable foot restraint for the operation to actually release the rollout solar array from its flight support equipment.
So you go for that tether and to ingress the APFR.
Okay. Now, Shane, you should have eyes on your tether because it's going behind my back. That's where it's supposed to be, but just making sure.
Do you not have eyes on it?
Can you move a little bit? And I think you can see it. Translate. Sorry. Station aft.
Down towards the tower, and I think it'll.
Yeah, you can copy your last, Shane.
Go around over towards the tower, and I think it'll help clear it.
No, I'm in the APFR. Good.
Copy, Thomas. Check your tools and tethers are clear and the ingress aid is stowed.
The ingress aid is stowed. Two the tethers are cleared.
You can give SS.
Ideal. Might be your teeth just a bit. One by one, just a bit, Jenny. All right.
Copy. Thomas, when you're ready, you can give SSRMS a go to maneuver.
I'd like Shane to have eyes on the tether because it's kind of on my back.
I have eyes on now, Thomas.
Yeah.
Got to about 2 feet above you is my tether.
Okay.
And I'll watch it.
Look good to you?
Yep, it's good right now.
That was my APFR look. Look good?
That looks great.
Okay. With that, Mark, I am ready for the maneuver to the ingress back-off position.
After we're putting that work, we'll give you a call when we start moving.
That's great. Nice work, Shane, off P6.
Well, thanks. You too, man. You were driving some serious bolts.
Starting motion, station forward.
Copy. That's a good motion, Mark.
Thanks.
Mark, stop motion.
Motion.
My tether now is up against the post. Can you go station nadir first or not?
We actually just completed the forward motion, so we can definitely go nadir. That would be our next step.
And Shane, I'll try to bend forward as much as I can.
I mean, I'm up almost against the...
Thomas Pesquet working with Mark Vandehei to properly position Pesquet at the fine-tuned orientation for the release of the IROSA solar array.
Me and Shane has the clearance.
Okay, thanks. Tether are cleared. Continuing station nadir.
Motion to ED2.
Copy, thanks.
Oh, you're now clear of my tether.
Thanks, Shane, for your help.
Operating like a utility worker at the end of a portable platform. Pesquet at the end of the Canadarm2, and the view on the right is from his helmet camera, being maneuvered into the proper position for the release of the IROSA solar array from its flight support equipment.
That manual maneuver is completed. We're getting set up for the joint OCAS.
Copy.
While we're getting configured for the joint OCAS, I'll get a glove inspection and HAP check from both Shane and Thomas.
Jenny, good gloves for me, and happy to dry.
Gloves EV2, dry out.
Copy. Good checks on EV1 and EV2. And for your awareness, we are having issues with HECA today, so I'll ask you a couple more times during this EVA, I'm sure, to power cycle and check for a green light. I'll get you both to do that now.
Okay, Jenny, no problem. I'll have a green light now, and I'll power cycle. Off. I call with a green light for EV1.
Copy EV1 and 2.
And 2 power cycle.
Copy 2.
Now we're a switch throw away from joint OCAS, 1 of 1 in Vern.
Thanks, Mark. I am ready for motion.
Starting that motion.
And I see good motion.
Two hours into today's spacewalk, Thomas Pesquet now being maneuvered toward the solar array at the very bottom of your screen. Shane Kimbrough nearby as he monitors this part of the procedure that will result in the release of the array, and then Pesquet will be maneuvered as he holds the array over to the P6 work site.
Coming over here tomorrow, looking good.
All right, thanks, Shane.
By the way, Tomas, this is a total of 2 minutes in the journal cast. I don't think I told you that earlier, so I'm not sure how far into that we are.
Okay, Mark, sounds good. And getting close to IROSA, so it's all good. Probably a bit more.
.30 seconds to hand over.
Happy Jenny.
All right, Tomas, we're setting up for a manual maneuver.
We are in a handover period between satellites on the tracking and data relay satellite system. We'll get our downlink video and communications with the crew back momentarily. 2 hours, 3 minutes into the spacewalk, Thomas Pesquet being maneuvered at the end of the Canadarm2 robotic arm down to the ISS rollout solar array, the second of the arrays being installed on the International Space Station to augment the power capability of the complex.
Tomas, we are ready for that maneuver to the GCA published.
Okay, Mark, and you said 75 centimeters body in. That sounds like a good published position. Start GCA.
Copy, start GCA. Started.
Good motion.
Thirty-five centimeters to go.
Motion. And Mark, you can stop motion right here.
Okay, I'm making stop the motion.
It's a good position. I'll call that GCA complete.
GCA complete. Brakes are on.
Copy, brakes are on. Nice job, you two.
Ground copies, brakes are on. Thomas, attach a RET to the scoop on the inboard IROSA microsquare.
Okay. Mark. Have a RET on the scoop.
Copy, we are prepping to release IROSA from the FSE. So Thomas, check your tools and tethers are clear and your ingress aid is stowed.
Tools and tethers are cleared. Ingress aid is stowed. My heels are in position. The cooling is good. Visor is up right now. Up, bring it down. Case. Now we're getting into the... That's right, Jenny.
Copy. We are going in tonight. We have 2 minutes until eclipse.
Okay. And now control the IROSA from my position.
Copy, and you might have said it, but to confirm your heels are secure in the APFR and your gauntlets are down.
Gauntlets are down. I didn't say that. Thanks, Jenny, and my heels are secure and Shane, eyes on them.
Okay, copy. So now you're going to work together to release IROSA. Thomas, when you are ready, you can give Shane a go to release the final FSE bolt, Charlie 11. I'll have settings for that in a moment, Shane. But a caution, prior to releasing IROSA, ensure that the FSE is not moving. And Thomas, you will keep IROSA pulled toward you to keep it engaged on the pin slot interface on the FSE until you are ready to release it. Following that final bolt release, Shane, you'll be installing the square scoop, 45 degrees toward Thomas, and then translating to clear IROSA from the tower grapple fixture.
Hey, good work, Jenny. I like the extra of pulling IROSA down. That's what I'm doing right now. Bolts. And Shane, I have control you. I go to bolts on the 11, I think.
I'm looking at 2 bolts here and just want to make sure I get on the correct line. I'm ready for setting.
Copy, you're looking for Charlie 11. It should be labeled. It's the larger bolt there. Let me know if you see it. Your settings are Bravo 3, counter 3.
I see the larger bolt does not have Charlie 11 next to it. The smaller one does. That's what's kind of confusing.
Checking.
Which one?
The small one, is that the stop block, Shane?
Maybe, yeah. Great.
Shane Kimbrough using the pistol grip tool to release the last bolt holding the ISS rollout solar array in place.
On one of those bolts as well. We're checking on additional words for you.
Okay. Copy on Bravo 3, counter 2 or 3?
Bravo 3, counter 3. And again, your socket should only fit on one bolt.
Copy, thank you. Second. All right, Tom, are you ready?
Let me 1 minute to increase my cooling. To increase my cooling. Just want to be sure.
How many turns are we looking for, Jimmy?
24 to 26 turns. The bolt will spring out when released.
27.
Okay.
And Shane, I can see in your helmet cam that you are...
You ready, Tom?
Yeah.
Shane, stand down. You are not on the correct bolt. Charlie 11 should be under the guard for the IROSA blanket, so further away from you. You should be able...
I'm not on any bolt yet, Jenny.
Okay. Just making sure that to confirm that it's the bolt with the cylinder.
Copy. Are you ready?
I'm ready, sorry. Yeah, I have control. I'm pulling down. Not an easy access.
It's a long.
Yeah, I struggled a little bit.
Body position here. Ready.
You can count your turns if you want to see that PG.
I'm driving.
Okay.
A couple more turns.
Yep. 7, 8.
All right, 8 turns here, Ginny.
Copy 28 turns on Charlie 11. The bolt should be sprung out, fully released. You can start your PGT, Shane.
That's some work.
Shane, you'll be installing the square scoop on the root.
PGT good.
Copy. You can install the square scoop on the root beam micro square near Charlie 11. Remember, 45 degrees toward EV1.
Work. Tomorrow, you have the IROSA, right?
I have the IROSA collection.
It's locked. I'm going to take my red off.
Nice, please, Ben.
You have the IROSA?
I have the IROSA.
The scoop is installed, Ginny.
Copy, Shane. Translate to the zenith outboard side of the FSE to assist with clearing IROSA from the tower grapple fixture.
I'm going to reposition.
Copy. And that'll be to the other side of the grapple tower.
Two hours, 14 minutes into the spacewalk. Pesquet and Kimbrough working to release the IROSA solar array from its flight support equipment. We're just about there.
That's the array when you translate up. Back.
When you're ready to release IROSA, Thomas, you can slide IROSA zenith to release it from the pin slot interface. And Shane, you'll be giving SSRMS a go for the lower IROSA back off. Again, we want your eyes on the clearance with the grapple tower.
Shane, you ready?
Yeah, I'm in position and I'm ready.
Okay. Light it up. Feels like it's released.
Pitching up on my end.
Yeah. Out of control. It's full and stable. Okay. And Shane, up to you for the maneuver.
Hey, Mark and Megan, you have a go to the back off position.
Copy. We're taking the brakes off, and we're going to move reference to Thomas' body axis 3 meters body up.
Copy.
We're starting that motion.
I feel good motion.
Copy.
And you tell me how to orient IROSA.
Yeah, I'm seeing good motion now.
Copy.
Hey, right there, Tomas.
Staying stable.
Oh, how's the rate?
Rate's perfect, Mark.
Copy. Megan's flying great.
Concur.
Nicely, looking great.
Copy.
It's settling.
We're moving slowly, but moving.
Tower clearance is good.
Copy. Copy. Good tower clearance.
If you can pitch it up a little bit, it's
Anywhere slowly.
yeah. No, be uncomfortable.
It doesn't really want to pitch up. It's stuck on something?
Okay.
You want to stop motion?
Yes, you can stop motion for now, Mark. I don't know if Shane is a good
Stop.
reason. Okay, copy motion stop. It's hard to pitch. I don't know. Maybe it's just me.
No,
No, nothing.
I don't see anything.
Okay.
Yeah, but I'm not saying either.
Try to pitch it from here a little bit.
Left a little bit. Moving free.
Yeah. Okay, now it's...
Almost 2 hours, 20 minutes into the spacewalk, the second IROSA rollout solar array now being extracted from its flight support equipment by Thomas Pesquet at the end of the Canadarm2 robotic arm, as visual assistance is being lended by Shane Kimbrough, who will move over to the P6 worksite at the base of the far left side of the station, where this array will be installed on the opposite side from which the 2B solar array was installed this past Sunday.
Started that motion.
Good motion.
Good motion.
Looks like it's settling again.
Yeah.
Stop motion, Mark.
Good motion.
I think it's on the my left, like on the inboard side. Feels like there's some friction.
Move it freely again. I just moved.
I don't know, it feels like it's touching on something.
Okay, good.
Can you translate zenith and look maybe? Look down from the zenith side of the FSE.
Yeah, Jenny, you go with me going over to the other side?
Yeah, we are. We're following along, Shane, and we agree you should go to the Zenith inboard side. Check it out.
That's in order. You know, hang around first. I'll just.
I need to copy your last, Shane.
I don't see anything right off the bat.
Okay.
I'm up on the Bravo stance.
You maybe try to push it up a little bit, like away.
I see what it is now.
What is it?
So it's hitting the, you know where we put that tip pin in, whatever that bolt was?
Uh-huh.
Coming up to that bolt, and it's just being stuck there. So,
okay.
You yaw it to your right a little bit.
Can you push it a little bit?
And Shane, you can deconflict it from that bolt. You can touch you can touch the bumper that your left hand is close to, the white bumper that protects the blanket.
I don't think it clears it, but yeah, Jenny.
It's clear now?
No.
No? Okay.
All right, to your right, Tomato.
Now you have to, I don't have, I think I'm hitting on the other side. Can you push it to yaw it to my right? Now it's hitting on the other side. What I can do though is roll to my left. I'm going to roll it towards you. I don't know if that helps, because I don't have eyes on the problem, but...
yeah, let's try that and see.
I'll roll towards you a little bit.
Out there. Stop.
Stop, okay.
And that'll definitely help. Mark and Megan, are you guys ready?
We're ready. What direction?
The standard direction of going, whatever.
It was before.
Whatever you were doing before, that way.
Okay, copy. We got a couple more meters to go. Starting that motion.
Hey, Mark, I'm going to go like 20 centimeters, and I'll stop you probably.
Okay, we'll go 20 centimeters and check in.
Roll to your left. Up. Mark and Megan.
We start the motion.
You can stop motion.
Motion.
That's not helping too much. You're going to hit that bolt.
We are following along. We suggest you might be able to move nadir, and hopefully the bolt could clear the gap. Oh, looks like you did it.
There you go.
Well done, Shane.
It's free now, Jenny. It's free now.
Okay. Okay, Mark, ready for you to resume. Jenny, you want me to stay here or go to the other side?
Shane,
I was looking for with respect to the tower, Shane.
Shane,
grapple fixture out there.
Can you see the tower?
No, I cannot see it. Sorry. Probably need to go back over there, right?
Yeah, if you...
Yeah, we're holding in place until you give us a go that you've got good clearance views.
Shane, we want you...
This bolt here.
Shane, we're happy with the clearance to the bolt, so we want you by the tower to view that clearance during the motion.
Yep.
.30 seconds from handover.
Two hours, 27 minutes into the spacewalk. Thomas Pesquet carefully removing the IROSA solar array from its flight support equipment. Very tight tolerances to get it out of the flight support equipment area. Under the watchful eye of Shane Kimbrough, who's alongside. We're in between satellites on our tracking and data relay satellite system. We'll get a downlink television and communications capability back from the station just momentarily. Everything continuing to proceed fairly close to the timeline for Pesquet and Kimbrough. Spacewalk that began at 6:52 a.m. Central Time, 7:52 a.m. Eastern Time.
We're looking good over here. Motion, tomorrow you have it, it's free. That appears to be. Our clearance is good. Copy. You're clear of the stanchions on the left if you want to yaw it to your left a little bit. Not required, but moving out to my left. Looks good. Copy. Switch it up. Looking good. Our clearance is good. I see that you're clear of the tower and the FSE. Copy, Shane. Nice work. Thanks for all the help. Copy.
Thomas Pesquet now in firm control of the IROSA solar array. It is now out of its flight support equipment structure. Shane Kimbrough will move over to the P6 truss worksite to receive a handoff of the array from Pesquet once Pesquet is maneuvered over to that location by astronaut Megan MacArthur, operating the Canadarm2 robotic arm from her robotic workstation inside the International Space Station.
How much more to go, Mark? Got 15 more centimeters. Okay, motion is stopped. We're setting up for a joint LCAS. Copy. Ready for motion. Mark.
Shane, you can perform a socket swap to the 5/8 2-inch socket on your PGT.
It's in work.
Well, we're one switch throw away from a joint OCAS. It's the first of 3. This one will take 2 minutes in Vern.
Copy mode. Those are the information, and I am ready for motion.
Starting the motion.
And good motion. Nice and smooth.
We get full test on the 12-inch on the socket caddy.
Copy.
So now we're set up for the second OCAS.
Copy.
Full test on the 2-inch on my PD.
Copy. Shane, after you stow your PGT, you'll be retrieving Thomas' green hook from the port CETA cart.
Copy that.
Now we're switching away from the second of 3 joint OCAS in Vern, 2 minutes.
Потому что сейчас же вам раскадрование удобно использовать до воскресенья? I have some motion shadow on the... Yeah. Okay, Mark, I copy. I'm ready for your second joint OCAS.
All right, that's from the RO motion.
Copy. I see good motion.
Copy.
Hey, Mark, I don't have visual references anymore, so if you can give me a heads up when the motion up so that I can control and prepare the IROSA.
Yeah, we'll give you. We'll tell you when we start ramping out.
Yeah. Great, thanks.
And Thomas, just for your awareness, some of these maneuvers will bring you close to the 2A solar array. It'll be on your left side. We understand you're in the dark right now, but if you do see it, we don't want it to surprise you. We have good clearance from the ground, and so do M1 and M2 from their procedure.
Okay. Many thanks for your heads up. I appreciate it.
And we're starting to ramp out.
Thank you, Mark.
Shane, when you pick up Tomas' green hook, make sure you attach it to your waist tether or D-ring extender or green reel.
Okay, copy that.
And Tomas, that motion's complete. We're setting up the third joint cast.
Yep. Thanks, Mark. Your call was great. I could nicely control the IROSA, and I'm ready for the third of May.
Jenny, I got Tomas' green hook on my left D-ring extender.
Copy, Shane. Check reel unlocked.
It was unlocked.
Copy. Translate to P6 for green hook location. Check gauntlets in place prior to crossing the Sarge.
Yeah, I'll check it right now. Gauntlets on.
Tomas, we are want to switch from a third of three joint casts. This one's going to be 1 minute long in Vern.
Copy, Mark. I'm ready for motion.
Motion.
We copy your check, Shane.
Ramping out.
Copy. All right, I see the solar array. Towards my feet, move it forward.
And that motion is complete.
Copy. Nice work.
So now we're setting up a manual maneuver. It'll be a GCA.
GCA from Shane, I guess.
Shane, you're looking for handrail 5311 for Tomas' green hook and 5388 for yours.
After that, thanks, Jenny.
Headed into insolation in 1 minute.
Copy. And I see you coming.
Yep, I'll be in zip. Follow me. Up there and set the green hooks.
Copy.
Okay, Tomas is on 5311.
Good words.
Houston Station station on 1, we're standing by for your go for the IROSA handoff maneuver.
I'm on 538832.
Copy. Check both reels unlocked.
And station on 1, big picture, we're just waiting for Shane to get in position and get a little better lighting, and then we'll give you the go.
And also, copy, this is going to be a GCA, so we got to wait for their calls as well.
With the unlocked, Jimmy.
Copy, reels unlocked. You're translating to handrail 5344, outboard of your APFR. We'll put in a fair lead there.
This is Mission Control Houston, 2 hours 45 minutes into the spacewalk. Thomas Pesquet has been maneuvered to the P6 worksite near the base of the mast canister for the large legacy or heritage solar arrays that you see in the field of view. Those arrays delivered years ago on the STS-97 mission to the International Space Station, the first pair of original solar arrays for station power. Shane Kimbrough is about to move into a portable foot restraint at the worksite to take a handoff of the IROSA or ISS rollout solar array from Pesquet, who transported that array out of the flight support equipment on the truss and was maneuvered by astronaut Megan McArthur at the end of the Canadarm2 robotic arm to join Kimbrough at the worksite, to which this array will be installed on a mounting bracket for its unfolding and unfurling, joining another rollout solar array that was installed for the 2B power channel of the station back on Sunday. This array in play today is for the 4B power channel.
Hey, Jenny, what's the handrail for the
5346.
Charlie? Gotcha. All right, third lead is in on 534.
Good words. Verify APFR settings, Fox 7.
Raw, black on black, first test, good pull test. The 12 o'clock, Fox. Work on the 7.
Good settings. You can ingress the APFR, and then we'll perform your checks prior to the handoff maneuver.
I got a set 7. There you go.
Copy, Shane.
Shane Kimbrough looking down at the Earth from 255 miles up as the International Space Station flies from southwest to northeast, entering an orbital sunrise over the Pacific Ocean.
All right, it's all set up, Jimmy, and now, right?
You can ingress, Shane.
Kimbrough about to position his feet in a portable foot restraint to accept a handoff of the rollout solar array from Thomas Pesquet. As we take questions on hashtag AskNASA, a Twitter user asks, does Thomas simply put his feet in the foot restraint and they are secure, or does he use something else to secure them? No, he simply slips his feet into the foot restraint. He is tethered to other structures at the same time to make sure he is securely fastened, but it's simply putting feet in a foot restraint, slipping those feet in to the foot restraint, which is attached to the various structures at the work sites. Another Twitter user, Wayne, asks, is the rollout solar array that was deployed last week actually supplying power to the International Space Station? The answer is yes. It is up and running in perfect fashion, supplying about 20 kilowatts of power, as will all the other solar arrays.
All right, tomorrow, they come in. All right, doing all right? I'm doing good.
Shane, now that you're in the APFR, check your tools and tethers are clear and your ingress aid is stowed.
The tools and tethers are clear. I just cleared my safety tether a little bit. Ingress aid is stowed.
Check your
Be ready for Tuesday.
visor, glove heaters, cooling are set. Your heels are secure and your gauntlets are down.
Visor, glove heaters set. Glove heaters are off. What else, Jenny? I'm sorry.
Heels are secure and gauntlets down.
Gauntlets are down.
Spacewalk communicator Jenny Seide providing Shane Kimbrough with instructions as he moves into a portable foot restraint to accept a handoff of the ISS rollout solar array from Thomas Pesquet, the International Space Station about to cross the west coast of Canada, flying just north of Vancouver.
Copy, Mark and Megan. I'm ready for the GCA.
All right, Shane, great. That GCA will be relative to Thomas' body frame. Will be 2 meters body in. How's that sound?
That sounds good. I'm ready.
Okay, we'll call that start GCA. Starting motion.
That's a good motion.
Copy, good motion.
And a good view of the second of the 6 rollout solar arrays to be installed on the International Space Station. Currently being held by Thomas Pesquet, about to hand them off to Shane Kimbrough. Here in Mission Control, the spacewalk being supervised by Flight Director Pooja Jasrani. On the right of your screen, seated in the white jacket, is spacewalk communicator Jenny Sidey, Canadian Space Agency astronaut, and to her right is veteran NASA astronaut Drew Feustel.
One meter to go.
Copy one, looking good. Pitching it a little bit towards you. Thank you.
.50 centimeters to go.
Copy.
.25 centimeters.
Yeah.
Continuing. .10 centimeters. .5. Okay, Shane, that's published. How's that look?
That looks great. You can stop motion, GCA complete.
Copy, GCA complete. Brakes are on. Go for IROSA handoff.
Let me get a red on it. All right. I can only reach one handle from this location, so we'll work together. I can reorient it as long as you let me know. You can put a hand on it. And okay, I have a red on it now. Okay. I feel you're taking control. I don't have control yet, but I'll get to the second hand now. Roll it to your left. Roll it to my left. That's okay. More? I think that's good right there. Okay, let it settle. A minute. Okay. Now, you can let go for a second. Let me reorient it a little bit. Okay, so I'm letting go of one hand. I still have one hand on it. Over here. Is that good for you? Almost. Okay. I have control. Okay, you have control. So release my breath. Try not to give motion to IROSA, because I have a big moment arm here. I move it. Okay.
Right, my red is, you have a red on it, right, Shane?
Correct.
Okay, my red is released, I have control, and it is nice and stable. So you're pitching down a bit. I guess that's fine.
Ground copies all.
Down, Shane.
With a good handoff, when you're ready, Thomas, you can give SSRMS a go to maneuver to the back-off position.
You're still pitching down, Shane, right? Have control? Can you get me?
I'm hearing you, Thomas.
Yeah. You're pitching down, right? You're aware?
I tried to pitch out to correct that, but is it?
It's pitching down. As soon as I let go of my hand, it's pitching down. I mean, down view. I see it's pitching down. Do you want me to bring it back up?
It seems like a good position, but no.
Yeah, but it's, as soon as I let go, it takes quite a rate.
Yeah.
Nice.
Okay. Okay.
Yeah.
I don't feel like it's moving at all.
Yeah, but it's moving. I can see on that end. It is still pitching down a little bit.
I pitch it up.
It's going down on my end.
Changing relative to me.
I think it's very slight on your end, but it's significant on my end. Like compared to when I let go, it traveled by 1 meter already. But do you have a structure in view at your feet or something?
Yeah, I do.
Okay, so you have a reference. So I'll let go. It's stable now. Got it? Okay. And Mark and Megan, go for maneuvering the back-off position.
Copy to go for the post handoff back off.
Looking good and stable, Shane. Nice work.
So, Mark, can you give us a tethers and tools check?
So I've, my tethers are cleared from the IROSA. My tools are nicely typed in. I am ready for motion. Everything's clear.
Okay, we're starting that back off maneuver. Starting motion.
Copy.
That motion is started.
Okay, motion started. I see good motion.
Copy, good motion.
Shane Kimbrough in firm control of the IROSA solar array. Thomas Pesquet being backed away from that location. He will get out of the foot restraint and then join Kimbrough back at the P6 truss worksite to begin the process of mounting the array onto the mod kit or mounting bracket that's at the base of the P6 solar arrays where the integrated electronics assembly is located.
So, now we're setting up for the first of 2 joint OCASs.
Right, Mark. Sounds good. I'm ready for motion.
Tomorrow, this is the first of two joint LCASs. We're one switch throw away. It'll be in course, 2.5 minutes.
Copy. I am ready for motion.
Starting motion. We haven't started that motion yet.
Copy.
Now we're starting motion.
All right. And I feel good motion.
Copy.
Station Houston, space to ground for everybody, big picture on what's next. So we're currently at EVA PET of just over 3 hours. Our working eclipse start is in about 37 minutes. We see the limiting consumable is EV2 battery of 753. Our plan when we get back to the egress position is after the tether swap, we're going to actually pull the APFR off the SSRMS and stick it in a nearby whiff, and we believe that's going to save us time on the other end and protect us in case we get into that third eclipse of the day. So we're looking to save some time on the other end. And that's the big picture for now. How copy?
V1 copies. 2 copies.
Copies. Tomorrow, that first joint LCAS is complete. Set up for number 2.
Copy. Ready. And Jenny, I think I see on the bouncing bracket that the right descent is engaged, shooting up from the bouncing bracket from I see here. Make a note for later when we get to it.
Yep, we copied Thomas, and we were expecting that.
Okay.
Tomorrow, we're switch throw away from the second of 2 joint LCASs. This one's in course, 2 minutes.
Copy, Mark. Ready.
Starting that motion.
Hey, Dre, where's Tomas taking that APFR? Sorry, I missed it.
Sorry, say again.
Drew called down and said you're going to move the APFR somewhere.
Yeah, I copy that.
Where are you going?
I don't know. It's sitting a reef nearby, but they'll have more words, I guess.
I have words on that if you want it now, Tomar.
I want it now. Thanks.
You'll be doing the tether swap, and then when you remove the APFR, you'll be stowing it in WIF 13, which will be on your left. It is on the A-frame. There will also be a WIF right in front of you, but we do not want to use that WIF as it's right in the way of the translation path coming inboard.
You're reading my mind, Jenny. Okay, that sounds good. I see the WIF 13 on the A-frame, the left of handrail 5311, where I'll do the tether swap. And I was looking at the one that would put the APFR in the way, so good call there.
All good words. And to confirm, you also will not need to change any of the settings on the APFR. When you stow it in WIF 13, your clocking will be 6. I'll give that to you again later.
Copy.
And that second adjoint cast is complete. We're setting up a manual maneuver. It'll be a GCA.
Copy, Mark. I'm ready for GCA. You have it published?
We do. We're still setting up, but it will be 4 meters body in.
That sounds exactly right.
Prior to GCA, Thomas, could you reset your HECA and check green light?
I have green light now. Off. On with a green LED.
Copy, thanks.
Tomorrow we're ready for the start GCA call.
All right, start GCA, Mark.
Starting GCA, 4 meters body in. Motion started.
See you.
Did you say good motion?
I did say good motion.
Okay, good motion. Three meters to go.
New motion.
Thomas, we've got 2 meters to go. Can you see that trending pin?
I see that trending pin. It's my left a little bit lower. I have a good vision. Clearance vision if you like.
Copy, good clearance.
This is Mission Control Houston, 3 hours, 13 minutes into the spacewalk. A good view of the IROSA solar array, the ISS rollout solar array, the second of the 2 such arrays being installed on the International Space Station. It's in the grasp of Shane Kimbrough. We had a view from his HD camera for a moment. Now you're looking at Thomas Pesquet being moved back to a position where he will get out of the foot restraint at the end of the Canadarm2. He transported the array over to hand off to Kimbrough after the array was released from its flight support equipment on the truss of the station. Pesquet will join Kimbrough back at the P6 truss worksite for the installation of that array on a mounting bracket at the base of the mast canister that houses the legacy or heritage, the original solar arrays for the P6 truss, to which this second rollout solar array is being attached to join the first such array that was installed this past Sunday.
5. And that's position. How is that looking, Thomas?
It's looking fantastic. It is great motion. GCA complete.
GCA complete. Brakes are on. Go for ATFR egress.
Copy. Brakes are on.
Ground copy.
Jenny, I am ready for my ATFR egress.
Okay, with your waist tether down on handrail 5311, check the gate is closed and locked.
On my right waist tether down on 5311, and the gate is closed and locked.
Copy. You can egress the APFR, and then we'll GCA if required in order to access your yellow hook and the APFR.
I am out of the APFR. Yeah, it'd be nice to have kind of 50 centimeters station forward, possible, or that towards body up if we were in internal coordinates before.
Yep, we copied 50 centimeters, APFR boot plate up or body up if you're in your old reference frame. Does that make sense?
That sounds good. That's perfect, Mark.
Okay, are you clear for us to start that GCA?
Yeah, I've actually have a hand on the finger state to keep it away from me. Can go for a GCA.
Okay, we're going to ramp this in slowly, starting with motion. And that's a start GCA.
Yeah, start GCA.
Copy, good motion.
With Megan MacArthur at the controls of the Canadarm2 robotic arm, Mark Vandehei providing visual cues alongside of her in the International Space Station at the robotics workstation. The robotic arm being backed away from Thomas Pesquet now that he's out of the foot restraint. He soon will be joining Shane Kimbrough back at the P6 worksite. Kimbrough with a firm grasp on the ISS solar array, the rollout solar array, the second of 6 such rollout solar arrays. A good view of those arrays right now that will be installed on a mounting bracket, unfolded and unfurled for the 4B power channel on the P6 truss of the International Space Station.
For now, but we'll go too far.
Okay, so we haven't stopped the GCA yet, unless you say to stop GCA complete.
I think GCA complete for now.
GCA complete. Brakes are on. That we think you're go for the APFR adjustment.
Okay.
And Thomas will complete our tether swap first.
Yeah, I copy.
The International Space Station is flying 255 miles over the Atlantic Ocean, midway between the east coast of South America and the west coast of Africa.
Put my left waist tether on the handrail 5232, Jenny. The gate is closed and locked, and I'll pick back up the one I have up here.
Copy. Release.
I'm ready for your words on the swap.
Release your yellow hook from the SSRMS and attach it to your green reel.
And I think I need 20 to 30 centimeters body in based on my previous position. Okay, Megan.
Copy. We can do that. 20 centimeters boot plate in.
That's right.
And you have the clearances there.
I have the clearances.
Okay, with that, we'll call that a start GCA.
Start GCA.
Starting GCA and starting motion.
Yeah, good motion.
Copy, good motion. Time to go.
To that position.
And that's the 20 centimeters you asked for, Tomas. How's that look?
Yeah, that looks good. Thank you.
So you call that GCA complete?
That's GCA complete.
Make sure on.
Battery brakes are on.
Ground copies, brakes on.
And my yellow hood, Jenny, green reel, locked black on black, and the reel, both reels are unlocked.
Copy. That is a good tether config. You can ret to the APFR and remove it from the arm.
My waist tether on the APFR, Jenny, that's fine.
That's fine, Tomas. Remove the APFR and install it in WIF 13 with a clocking of 6.
It is sticky. And collar knob is very sticky, Jenny. I need to move a little bit. You're doing, Shane?
Good, man, thanks.
We copy, Tomas.
Got it. Okay. APFR is out. You said WIF 13.
A-firm. It should be on the A-frame near your left hand. We're looking for a clocking of 6.
Okay, in work. Read on 112.
6.
Copy 6.
Jenny APFR is in, clocking of 6. Those are out, black on black. Have a good full test.
Good APFR install, Thomas. Check your tools and tethers are clear from the arm, and you can remove your tether to the APFR.
Approaching the 3.5-hour mark in the spacewalk today by Pesquet and Kimbrough. A good view of Thomas Pesquet, EV1 or extravehicular crew member number 1, wearing the suit with the red stripes. He is stowing the foot restraint that was affixed to the end of the Canadarm2 robotic arm that he placed his feet into to ride the arm, carrying the ISS rollout solar array to the Port 6 truss worksite, where Shane Kimbrough is patiently waiting for Pesquet to join him to install the array that you see here in the field of view from Kimbrough's helmet camera with the Earth below. That array will be mounted onto a mod kit, as it's called, basically a mounting bracket at the base of the Port 6 truss structure. Then electronic cables will be hooked up to join the new array to the integrated electronics assembly for the 2B, for the 4B power channel. In this case, the 2B power channel received the first new solar array this past Sunday. The crew then will be using a pistol grip tool to disengage a series of bolts to enable the array to be unfolded and unfurled and tensioned so that it can begin to draw electricity during daylight passes of the Earth. Each of these new arrays will be capable of producing about 20 kilowatts of electricity to augment the current power output of the station's older solar arrays. In all, 6 of the 8 power channels on the station will receive arrays, those power channels drawing the greatest loads or the greatest requirements for electrical consumption for payloads and other hardware that they are associated with. The technology from these rollout solar arrays that are being installed on the space station is also going to be used in the Gateway program in lunar orbit. The Gateway is an outpost under development that will orbit the moon, providing support for a long-term human return to the lunar surface and a staging point for deep space exploration. The arrays to be used for the Gateway program are, and particularly for the power and propulsion element of Gateway, will be a bit larger than the rollout solar arrays being installed on the space station. A single IROSA or station rollout solar array measures 60 feet by 15 feet, while the solar array wing contemplated for Gateway will be 60 feet in length and 32 feet wide. The 2 arrays to be installed on the power and propulsion element of Gateway in the future will produce about 60 kilowatts of power. Gateway to use the power to move around the moon while performing lunar exploration tasks, technology demonstrations, and other experiments.
The incremental yaw is looks like the setting of 2. Okay. All right, Shane. You ready? Ready. Okay. So it's going to be to your left. Correct. And here's your first click. Go down. Yeah. Oh, it's your in the click now. That's 6. How's the orientation of this, Sonny? Orientation in terms of IROSA? Yeah, I go on the stretcher over there to my left. Are we good? Yeah, we're good, but you'll have to pitch up a lot when we get to the end. At least 60 degrees of pitch. Put some of that in now, real quick. Okay. Looking better? Yeah, looking better, but you're going to need more. But I'm going to ramp that out, though, and then I'll let you go ahead. Okay.
Ready. Ready.
All right, there's, you can click. All right. And you're out of 6, going down to 5. I'm going to click in 5 and I'll tell you. Click in 5.
Ramp it out. Pitch. Come on, I'm ready for the next yaw.
Okay. Out of 5, going to 4. A lot of work to. Click in 4.
Are we looking to structure?
Need 40 degrees of pitch or 30 degrees of pitch at least.
Better or not?
Yeah, better.
Ready when you are.
Okay, ready for one more click. Out of 4, going to 3. Click in 3.
Okay.
Better with, yeah, so the IROSA is close to the HFR, but we still have some clearance.
See that?
Yeah, the height is good for now. You pitch it up even more, better. Or, yeah. Now.
I'm ready.
Okay, ready for the final click?
Yep.
Out of 3, going to 2. In 2.
You just get your boot plate when you get over there and see if that's out or not. Hey, Lamar, I think I'm in good position here.
Okay. Resume my translation to my APFR position.
We copy you're in a good position, and we copy the clearance of IROSA to structure. Well done. Thomas, ensure that Shane's tether is clear for his egress later.
I'll go under the APFR.
Thomas, you're translating to handrail 5360 outboard of your APFR.
And pitch up.
I'm watching it.
It has a tendency to pitch down.
Yeah.
P5360, Jenny.
A-firm, you'll be fair leading your safety tether on 5356, just nadir of 60.
5356. B.
3 hours, 35 minutes into the spacewalk, Thomas Pesquet, as you can see from this view from his helmet camera, moving into position to join Kimbrough at the P6 worksite, where he will take a handoff of the array back from Kimbrough now that he has stowed the one of two articulating portable foot restraints in play for today's spacewalk. Once that second handoff is completed, the crew will then receive instructions from the ground IV or spacewalk communicator, Jenny Sidey of the Canadian Space Agency, to begin work to install the rollout solar array to a mounting bracket at the base of the P6 array for the 4B power channel.
India, Foxtrot, and Bevan.
Back with you after the handover. Repeat your last.
Bevan looks right. Yes. Bevan looks right. 12 India, Foxtrot, 11, Jenny.
We want to confirm settings of Fox 11.
Yeah, 12 India, Fox 11, Jenny.
Okay, copy. We're caught up, Thomas. You can ingress the APFR, then we'll do our checks.
Okay. And Shane, you have to yaw the IROSA to your left if you can. Good. More. Okay.
Thomas, mind the clearance between your helmet and the IROSA blanket.
I see it, Jenny. I'm doing my best.
Understood.
Yeah, I'm in the APFR. Okay, great.
Copy, Thomas. Ensure tools, tethers clear, ingress aid stowed.
Yeah, all that is good.
We are 2 minutes until eclipse. Set your visor, glove heaters cooling.
All good, Jenny. Thanks.
Heels secure in the APFR and gauntlets are down.
Okay, he'll secure and gauntlets are down.
Okay, with that you can work together to transfer control of IROSA. Keep in mind you'll be performing a RET swap, and it's important, Thomas, that the RET goes on the scoop in your left hand.
Your left scoop. Okay, that makes sense. And Jen, if you're ready, can you pitch it up from your position? Not much authority there. Up, pitch up. All right, man. Yeah, I didn't copy your lesson, but I'm trying. I don't have much authority, but okay. If you bring it up a little bit, then I can help. Right now, I only have the blankets, but There you go. Okay. I'm helping you pitching up. Okay. You hold it there. Set a red on the scoop. Yeah, the red on the scoop. I have a hand on the scoop. Okay, I have control, but I'm sideways, so.
Yeah, no, let go. You have control.
But no, stand by. So I'm more than 90 degrees sideways, so I'm gonna have to rotate the whole IROSA 90 degrees. I'm gonna need you to initiate that motion very slowly once you let go, and then I'll try to stop it. That make sense?
Alright. On to you.
Okay.
Alright.
I have a hard time hearing you, Shane. You're breaking off all the time.
Yeah, say again what you want.
So I want you to remember the final position. So I need your end to rotate. The left shoulder axis of rotation is my end. That make sense?
Yep. Once I release it, then you have control. You have control, right?
I have control.
I'm gonna let go.
Yeah.
I'll get my red off. Off.
Okay. I have to be very stable in pitch. And I just need a little bit of yaw.
You have a hand on it?
I have two hands on it, but on the same scoop.
Are helping?
You'll have to push it.
Yeah, that's what I'm trying to do is push.
Keep yaw. I don't see it, yaw. Push it and let go is what I mean, Shem, right?
Oh, gotcha. Okay. Taking that.
Very slowly. Yeah, that looks good.
Better?
Yeah, I can control that.
Have it?
Have it.
I'm gonna let go and get out of the.
Well done, Tomas and Shane. Shane, understand you're egressing the APFR. You can release your fare lead and head to the mod kit.
Oh, okay, come on.
I'm trying to have good control here.
Very good.
Big yawing very, very slowly. Bring it home.
Yep. Let me get set up and get my fare lead off, and I'll be.
Ground copies.
EV crew, warning and caution for you while Jenny's taking a quick break. One on the aft side of the mod kit. On the outboard side, avoid contacting the legacy blanket boxes and protruding trunnions. And a caution, while both crew are working on the mod kit, crew must not simultaneously impart loads into the mod kit. That's translation unfolding IROSA, bolt ops, connector ops, or cable routing. Sudden stops and quick grabs are not allowed on the mod kit. 30 pounds max lateral load on mod kit during and after IROSA soft capture.
Copy, Drew. Copy, Drew. Something like a butterfly on the mod kit. I'm in a good position now, Shane. Push.
And I'm coming over to you. Over here.
And Shane, for you, you're translating around the left side of the mounting bracket. Don't forget the fair lead around the IEA corner on handrails 5336 and 5340.
So up now, and then I'll put a rich man fair lead, same place I did.
Copy that, sounds good.
What's going on tomorrow?
Morning, Shane. Okay.
Shane, we see you trend.
I had to try to above you.
Hey. On the left side of the bracket is the
We copy.
lower strut upper hand.
We copy, Shane. We need you to check the left soft capture features are armed and down.
Left and are armed and down.
Copy. We're going to work to install IROSA on the mounting bracket. Make sure the bottom of the root beam is aligned with the mounting bracket alignment features prior to installing. And caution, confirm no BGA motion prior to installing IROSA on the mounting bracket. Shane, you can maintain control of IROSA, assisting Thomas as he uses the adjustable equipment tether hook, the long side, which is stowed on the mounting bracket scoop, to tether to and remove the scoop in his right hand.
So it's too far, Jamie. It's too far in my back. I don't think I can do that. I expected. So if you could, maybe you have to go the APFR. I'm sorry, but not a lot. I have a handrail tomorrow. I have a handrail. Can I bring it towards you tomorrow? If you have control, then I can yaw myself. I have control. Okay, you have control. One hand on it. Yeah, because the red is pulling it towards me. Able. Going that way. You know what? I'm going to try to put the... All over. Over with it. Yaw a little bit. There you go. Oh, nice. Okay. Okay, I'm back in. You found me. Life is good. All right, 80 scoop. Done. And release the scoop. Correct, Jenny?
Affirm. Remove the scoop.
Sure. It's gone. And I'm going to resume control. Okay. Control. Can you help me bring it back up? I'm helping. Yeah. In pitch and then stabilize it nicely parallel.
This is Mission Control Houston as we approach the 4-hour mark into today's spacewalk. Thomas Pesquet and Shane Kimbrough in the third spacewalk in the sequence, currently underway to install the first 2 ISS rollout solar arrays onto the P6 truss structure. For that portion of the integrated electronics assembly for the International Space Station, these arrays to augment the current power output of the station's systems. The 2 spacewalkers are in the process, the early stage of installing this second rollout solar array to a mounting bracket at the base of the P6 truss, after which it will be unfolded, maneuvered into place to alignment guides, hopefully without much trouble, and then to have electrical connections made through a series of cables pre-staged by Shane Kimbrough earlier in today's spacewalk.
Yeah, but something's pulling on it because it's cable and suddenly it goes pitch down really fast. Try to hold it down on my end, right? But don't pull it so that it pitches. No, it's too much. That's too much. It's making it pitch down and it's not aligned. It's your end down. You have to bring it up on your end. Sure. There you go. More. More up? Yeah. There you go. Okay. Now, how does it look like sideways? They come to you just about 10 centimeters. Right. Lined up? Lined up? Yep. Do you want to go in? Okay, where it's stable. Pitching up on your side. Maybe 3, 2, 1. What's going on? It's in the hole. It's in? Yep. It's just not getting all the way. No, it's not in on my side. The hole on your side now. Yep. That's a matter of angle. There we go. Not in on your side though. Okay. It's only the angle. You're still line it. Like in
to be really flat. Control for a second, I'm going to read. Have control. All right, I'm in. I'm in too. Thanks. The defense engaged. Around this thing.
Shane, you're coming across broken.
He's checking that the defense are engaged. Lineman guys are engaged, both left and center, and we're checking the defense.
Copy.
It'll take a minute, Jenny. The A-frame gets in the way. It's a bit more exciting, a bit more challenging than the previous one.
To confirm, you have both alignment features and both soft capture features on the left side.
Oh, negative, Jenny. We have both alignment features and we are checking the defense, the soft captures. That's what we're doing right now.
Copy, we're with you.
Okay, both the soft capture fans are in, center and left. Correct. The lineman guys are in, center and left. Yep.
Copy, we understand. Well done, you two. Thomas, you can release your RET, and you'll be using the adjustable equipment hook on the mounting bracket scoop to attach to the scoop, which is in your left hand.
Copy. Right above you.
Shane, you will be connecting the adjustable equipment tethers, which you pre-staged, to the left side of IROSA.
Okay. Back around this way. Jenny, the AT from the mounting bracket scoop is now on the left scoop, and I'm going to go ahead and release the left scoop and go back to the bag.
Good words.
This is Mission Control Houston. We have hit the 4-hour mark into today's spacewalk by Thomas Pesquet and Shane Kimbrough. They have mounted the IROSA array, the ISS Rollout Solar Array for the 4B power channel of the International Space Station and have achieved a soft capture onto the mounting bracket at the base of the Port 6 truss structure of the International Outpost. With that having been completed, the next step will be for Pesquet to use a pistol grip tool to release a final hinge restraint called the inner hinge launch restraint on the array. That will be the precursor to the unfolding of the array, hopefully with less trouble than was experienced with a structural interference on the first spacewalk conducted 9 days ago. On that occasion, for the first of these two arrays, a structural interference resulted in the array being refolded into place. A series of troubleshooting steps were implemented to enable Pesquet and Kimbrough to unfold and unfurl that array successfully this past Sunday in the second spacewalk they've conducted.
Equipment tethers to the left side of IROSA. Following that, we'll be able to release the final hinge restraint bolt R6, so you can ready your PGT.
The timing of today's operation requires the International Space Station to be orbiting in darkness or eclipse at the time that electrical connections are made, so that we don't have power flowing through the integrated electronics assembly while those connections are being hooked up for the new array to the electronics assembly. We're 15 minutes into this current night pass of the International Space Station. Flight Director Pooja Jesrani has informed the team here that we will not get to those electrical connections during this pass, and we'll wait until the next night pass to begin that work, pending the other activities that will precede that, including the unfolding and securing of the array in an unfolded alignment configuration.
Releases the final hinge restraint bolt R6. Tomas, stand by for settings until Shane's in position.
I can set now and I won't drive until in position. But that's very interesting.
Tomas, your settings are Bravo 2, counter 2. I'm waiting on Shane's position.
Bravo 2, counter 2, I don't understand. I have to wait for Shane.
Good words.
Hey, Tomas, I'm ready whenever you are. Good.
Tomas, you're releasing R6.
How many turns, Johnny? You didn't say?
You're releasing R6, 18 to 20 turns. The bolt will pop out.
18 to 20 turns. All right, R6. Jenny, I have 19 turns and the bolt popped out, fully released.
Copy, Tomas, 19 turns, R6 is released. You can stow your PGT and egress the APFR. I have big picture words for
All right, Shane. Great position. All right, releasing it. Open it up. What? Gonna open it up. There's a scoop in the way.
Well, I'm back with you after the handover. Tomas, your next step is to relocate the APFR.
Are we not opening IROSA first?
No, your next.
Shane's standing by with a hand on it. So.
Your next step is to.
Again, let's do it.
Your next step is to relocate the APFR.
Okay, cool.
Yeah, okay, we don't need that APFR now, Benny. I don't want to keep Shane waiting like this for too long, but no call.
I understand. You can open it up and tether it first if that's better for both you and Shane.
I think it's better, so we'll do that.
Understand? Do that. Warning, pitch point, keep clear of rotating IROSA. Thomas, make sure that you are on the outboard side of the mounting bracket.
Copy. Pinch point, we'll make sure.
So I'm going to you.
I have control.
You have control.
So I'm going to magically engage Shane.
Oh, it's going to be awesome. Looking forward to that.
The two spacewalkers now are beginning to unfold the rollout solar array to its full extension. The array will be tethered into place for a short period of time while we reconfigure foot restraints prior to the point at which the two spacewalkers will attempt to straighten it to its full extension.
The others, but... Okay, I'm on the tethers.
One on the handrail that you're holding on to, and there's one above you.
Yes.
Up yet?
Yep. Okay. Got one. And two.
Nice.
Okay.
Well done, you two.
Same situation as on the other side. No surprise there.
Copy.
Stars alignment.
Thomas, you can ret to the APFR. We'll move that to the center inboard side of the mounting bracket. And I have big picture words for you both.
I'll take a minute to adjust my cooling because I'm still on my SSIMS-1 cooling. I've been working it before.
Copy.
You can go ahead with the words, Jenny. We're listening.
Okay, well done unfolding IROSA. We are going to continue with the install steps on the mounting bracket. We are not going to complete connectors during this eclipse, so we're going to prioritize getting IROSA in a stable config on the mounting bracket. Your PET is just over 4 hours, limiting consumable 7 hours, 55 minutes, EV2 battery.
Copy all.
We'll have more big picture words on when we're doing those cables shortly, but again, we're pushing with bolts at this time. So Thomas, you have your next steps to relocate the APFR, and I'll take a glove inspection, hap check, and gauntlet check from Shane.
Okay, Jenny, on my left-hand gloves, so my middle finger, ring finger, picture just have some smudges on them. And right glove looks good. My hat.
Copy. Check gauntlets down.
Gauntlets are down.
Copy. Well, Thomas relocating the APFR. Shane, you can stow your green PGT on the crew lock bag and stow your long duration tie-down tether.
What's the long duration? Okay, gotcha. I just keep my PGT if that's all right, and we'll just hand it back and forth. Yeah, yes, that.
No problem.
Spilling it.
This is Mission Control Houston, 4 hours, 11 minutes in to the spacewalk today, the second ISS rollout solar array has been unfolded from its stowed configuration following its soft capture onto a mounting bracket at the base of the P6 solar array truss structure. At this point, Thomas Pesquet and Shane Kimbrough will continue work to more securely fasten the array to that mounting bracket, will not attempt to hook up electrical connections during this particular night pass of the International Space Station. The flight control team here wants to do that in a slow and methodical fashion. Those electrical connections must be mated during an eclipse or night pass of the Earth to make sure that they're not hot, if you will, that there's no power flowing through the integrated electronics assembly during the night time orbit of the Earth. We will get to them. We're just going to have to wait for the next nighttime pass by the station.
On the pitch.
A firm Fox Fox Hotel 3.
Hotel. And 3. Talking of 9.
Copy, installed, clocking 9.
For situational awareness, the next night pass of the International Space Station, where the electrical connections can be made, is about an hour from now.
The other whiff doesn't really stick. Oh, yeah? Okay, now it's in, pedals out. I have a good pull and twist test with 37. Awesome.
Copy, Thomas.
Okay, what's next, Eddie?
Thomas, can you verify that the right soft capture feature is armed down?
Now, if we didn't touch it, I reported before that it wasn't, right? From the SSIMS.
Yeah, this is the right one. If it's not down, we want you to pull it down.
Yeah, but you said it was expected.
It was expected that it deployed,
Okay.
but we want you to reset it.
Okay, got you. Got you. So now it's reset. Groove. Nice.
Copy, Thomas.
What's next?
Thomas, translate to the outboard side of the mounting bracket. And Shane, for you, you are going to pull down the middle soft capture feature and cinch the adjustable equipment tether taut to hold the pin down.
Can I have the APSR or what do we do?
You can. Your next step is to ingress the APFR, Shane. So if you can reach it better from there, that's fine. We're coming into insulation in about a minute.
Heads up, Jenny.
The head clearance with that P4 Shane. Sorry, intersect. Not early, the other day. Yep, good. Okay, Jimmy, for Shane again, what's the next steps?
You're in.
Down the center. Yeah.
You're going to cinch the adjustable equipment tether on the middle soft capture feature taut so that the soft capture feature is held down or armed.
Copy.
Tuma, you're just standing by. We'll sync up and then we'll have an installation attempt. But I'll give you words on what we're doing before that.
Okay, Jimmy, it's cinched down and it's full open in the center.
That's a good config, Shane. From my understanding, only the leftmost soft capture feature should be up or deployed, correct? Okay, so big picture, with the leftmost capture feature engaged as it is, we are going to straighten out IROSA. Tama, you're going to pull outboard. Shane, you will push the right side toward Tama, but ensure that IROSA stays fully unfolded by pulling the left side near the hinge inboard toward you. Again, we're going to try and straighten out IROSA and then install it on the mod kit.
Shane, it's a matter of angle. We're right in the middle of the slot, but now you have to maneuver it in pitch. That's right. Okay. So I'm going to pull out my side, push on. Yeah, but the pulling I can do. What I cannot do is angle. Okay. So try to pitch it up. Just start coming out slowly. Try to anyway. And pitch towards you, right? Your body axis. Pitch up as if you were flying. Yep. Yeah, but it's pretty level here. I can't pitch. Pitch down. It's right there, but it's just not going in. Try to push on it. Your side. Yeah, I think it's a misalignment of just slightly. Try to pitch you down slightly. And pushing on it. Pushing on your side. It's like last time. I'm kind of pitching on it. You're kind of what? Pitching it towards, pitching down from my perspective. Try to pitch it up from your perspective. Okay. Actually, I think it's in the middle, so I'll try to go slowly as you pitch it. Push. There. Now, from your perspective, are you pitched down or pitched up? It looks level because it's just metal on the mounting bracket. Yeah, but there's 1-2 degrees, and I think that's what prevents it because it's right, just like last time. The alignment guide is facing the slot, really nicely in the middle. It doesn't go in because of the pitch, I think. Okay, so I'm going to try to pitch up. Pitch down now. Pitch down. Okay. Don't go anywhere, I'll do like last time. I'll come forward. Give me more force. Okay. Ready? Yep. 1, 2, 3. Try to make the lining even more pull on the center part. Pull on the center. Pull towards me. Yeah. And then push. Okay. Okay. It looks like it lined there.
Well done, you too.
Okay, cool, and then ready for pushing? Pushing things fully?
And Thomas, check the rightmost soft capture feature is down.
That's a good call, Jenny. It is now up. That's why we're not going anywhere. A good call. Okay, now it's down.
4 hours, 22 minutes into the spacewalk, Pesquet and Kimbrough using the troubleshooting methods that were developed following the first spacewalk back on June 16th.
All right, Ren. Ready. We're done. Soft capture is up.
We copy. Well done, you too.
That's fun.
All right. So at this point, hardware meets the minimal structural configuration for mating cables during eclipse. We are going to push with driving R7 and R8, the hinge bolts. Shane, you're currently in position, but we understand you might want Thomas to drive these bolts.
All right, you can drive for sure. On my PGT.
The two spacewalkers using a bit of elbow grease and the troubleshooting techniques of jostling the array into its firm capture position achieved success, setting the stage for the driving of a series of bolts, hinge restraints, to make sure that the array is securely fastened to the mounting bracket at the base of the P6 solar array truss structure.
I'm hopping out. Thank you, sir. Obstacle. Broken shape. Oh, tomorrow I gotta come back out. Good, sorry, what? Gotta come back around the safe frame, sorry. That's good. I'm out around, nice. Hey, Jenny, I'm ready for setting, so all right.
Alpha 1, clockwise 2.
Alpha 1, clockwise 2.
We're driving these bolts 13 turns only.
13 turns.
Jenny Seide, the Canadian Space Agency astronaut who's the spacewalk communicator, providing guidance to Kimbrough and Pesquet as they now will use a pistol grip tool to drive a pair of bolts. Those are hinge restraints to make sure that we are in the process of securely tightening up, if you will, the unfolded solar array to its mounting bracket at the base of the P6 truss. So it's unfolding followed by unfurling to get this array out to its full length of 60 feet to begin generating power to augment the current power output of the P6 arrays.
Then you have 13 turns, Alpha 1, clockwise 2.
Copy, 13 turns on R8. If you can reach R7 from your current position, we want 13 turns only on R7, same settings.
Okay. Turns on R7, same settings, Jenny.
Copy, 13 turns on R7. You can stow your PGT. Once Shane is ready, he can hand you the AMS knob from the crew lock bag.
Yeah, I'm just building my wire tie here. Okay. Okay. Can you hear somewhere? Yeah, it's going to be buried on that side. Okay. Have to pull out everything. Is that okay? Yep. Well, I can help you now. Yeah.
While you're in the crew lock bag, we'll also need the cap keeper shortly.
Okay. Cap keeper.
We're looking for the AMS knob first.
Got it. And now 2 turns, right? Anywhere for you on the R8, Jenny.
Copy. You're just looking to tighten until snug.
Returns. Yeah, 4 turns, Jenny, R8, snug. Now hop off the ATFR to access R7.
A firm, and I copy 4 turns R8 snug.
Sorry. Jenny, just so I got the wire tie in my trash bag, and I got the adjustable that was attached to it as well on my mini.
Copy, Shane.
And I'm ready. Snug. Back to you, Shane. Okay, and the cap keeper's right there.
Same number of turns, Toma?
4 turns, Jenny, just like the other one.
Copy, 4 turns. R7 is snug. You're right. Next step is the cap keeper. We'll be removing the NZGL caps on IROSA.
Right, so you too far. Comfortable. All right. NZGL.
Shane, if not already complete, you can stow the scoops in the crew lock bag.
Okay, I'm going to wait till all this is done. So.
Understood.
Whew. Tough one? Yeah, it was cancer. Snug. All right. God. Nice mountains. Yeah, beautiful. Must be Canada. Back to you.
Copy. All 4 NZGL caps are removed. You can stow the cap keeper in the crew lock bag with the AMS knob and the scoops. Shane, I have a big picture update for both of you.
Go ahead, Jay.
We are 4.5 hours into our EVA. That's a PET, 4.5 hours. Our next working eclipse start is in 43 minutes. So at this time, we are going to continue with driving M bolts. We'll get NZGL connectors mated at IROSA, and then we will push to cleanup steps to get ourselves in the best possible config prior to the eclipse, and then look at mating cables and finishing up.
Sounds good. Sounds good.
And our limiting consumable is still EV2's battery at 7 hours, 50 minutes, 50.
Hey, Jimmy, I got everything back in the crew lock bag.
Okay, copy. Well done, Shane. We're going to be using your PGT to drive M bolts. Understand you want to split these bolts up. We do not need to be in the APFR to do them, and we'll start with M35.
This is Mission Control Houston, 4 hours, 34 minutes into the spacewalk by Pesquet and Kimbrough. You heard the big picture words from spacewalk communicator Jenny Seide, indicating that we are now going to press ahead since the array is structurally secured to the mounting bracket at the base of the P6 truss. Pesquet and Kimbrough will work in tandem to drive a series of 8 attachment bolts to further secure the array in place, after which new cables will be mated to the rollout solar array connectors. They can be connected prior to the International Space Station flying in a nighttime pass. The eclipse or nighttime pass connectors that are required mate the new cables to the current solar arrays on the International Space Station so that we have an integrated power capability through the electronics assembly for the P6 truss power channels, those being the 2B channel that was hooked up last Sunday and the 4B channel that's in the process of being hooked up today. So we have to wait for the next nighttime pass of the station that occurs about 43, 44 minutes from now in order to be able to hook up new electrical cables to what is called the legacy solar array wing, the existing solar array wing on the P6 truss. The crew is making good time. We are assessing what kind of get-ahead work in cleaning up some of the tools and tethers used earlier in the spacewalk, what sort of work we can do to get a bit ahead of the game while the crew is waiting for that next nighttime pass to take place to finish up the actual electrical connections of the new rollout solar array to the International Space Station.
One black on. But should get to a 40 knot great.
Back with you after handover. say torque turns and green light.
Hey, sir, red shape.
Again for 35.
Stand by, Jenny. Stand by. Bye. Okay, M35 is driven. I got green lights, 22.2 torque, and I have 1155 revolution. 34 is next.
Copy, 22.2 on the torque, green.
Black on black.
Green light.
Black line flush, Jenny.
And 11.5 turns, black line flush. You can move on to the next bolt, Thomas.
Yep, M34, same settings.
Bravo 5, counter 2.
Settings. Bravo 5, counter.
Correction.
The only one I can get.
Thomas, correction. Bravo 5, clockwise 2.
Bravo 5, clockwise 2, yep, same settings. Bravo 5, clockwise 2. Shane, go ahead.
I can get 31 here in this position, and that's probably it. So, but I can come around the stand.
I can get those 4 here.
Okay.
And then you get the one on your side.
Okay.
Hang out.
And for EV2, I got my large, small adjustable and my small adjustable to IROSA on my workstation.
Copy, Shane.
Any on M34 have good torque, 22.1 green lights, and 9.93 turns.
That was M31, green light, 9.13 on the turns.
Oh, M34. M34, 34.
I copy M34 and repeat the torque.
22.2.
22.2. Confirm black line flush.
Black line flush.
Copy M34.
Which is the next one, Jenny?
The remainder of the bolts, the order doesn't matter, but on your side, I show 36 through 38.
The labels and go.
He's going for 32.
32. It's my turn.
Okay, Tomas going to get all the bolts except for 31. Just do the. I'll get 31.
Copy.
Okay, that was M32. 22.4 turks and 12 revolutions. Black line flush, thanks.
Copy and confirm green light and torque.
Green light and torque and 22.4.
Copy 22.4 green light. That was M32.
Yep, correct. Okay.
33 is next. Hold it tomorrow.
We'll have to push it up, otherwise it slides down the bolt. Thanks for the help. Again? Okay. 33.
Yep.
Good, Jenny, M33, green light 22.2, 11.87 revolutions, black line flush.
Copy M33, torque 22.2, 11.87 on the turns, green light, black line flush.
Right, and Shane's going to drive next bolt. She's in.
This is Mission Control Houston, 4 hours, 41 minutes into the spacewalk.
Shane is driving.
Thomas Pesquet and Shane Kimbrough, both using pistol grip tools in tandem, driving a series of 8 attachment bolts to further structurally secure the new ISS rollout solar array to the mounting bracket at the base of the P6 truss structure. The array was unfolded and structurally secured to that mounting bracket. Now it's being mechanically attached through this series of 8 bolts.
Getting 22.0 on the torque, 11.04 turns, green light, black line flush.
Copy, and that's M31, 22 on the torque, 7.04 turns, green light, black line, flush.
You want these now? You want or stand by? Your team there.
Is it your plan to complete the remainder of the bolts, Thomas?
Yeah. Yep.
Okay, copy. So I have
That's what we're going to do.
Thomas driving M36 through 38, and Shane, you can start mating NZGL connectors on your side.
Okay, and Jenny, I have a Bravo 5 clockwise to M36.
Copy. Good readback.
Jenny, green light, 22.5 turns, 12 revolutions, black line flush, M36, getting ready for M37, should confirm the same settings.
A-firm, same settings.
I'll wait on you tomorrow because I gotta go around this thing, driving bolts. That's right? Yeah, keep driving bolts. Okay, I keep driving bolts. Good, Shane. I got Bravo 5, clockwise 2, or M37.
Good words.
Hi, Jenny, and I have 20. Yeah, good green light, but low, kind of a lower torque-ish, 20.1 at 14 revolutions, M37.
Copy, M37, 20.1 torque, 14 turns, and green light, confirm black line flush.
Black line flush, sorry, my bad. Yeah.
Copy.
I'm going to be working on, sorry, the one that's outboard.
A-firm, that's M38, the final bolt, M38.
38. Same settings, Jenny.
A-firm, same settings, Bravo 5, clockwise 2.
Bravo 5, clockwise 2. Work.
Shane, let me know when you're ready for NZGLs.
Well, I gotta wait to get around safer until tomorrow's done driving here.
Copy.
Roger, you have black line flush, green light 22.4 turns, torque, and 12.83 turns on M38.
Copy, M38, 22.4 torque, 12.53 turns, green light, and black line flush. You can give Shane's PGT back to him if you haven't already, and we'll have you retrieve the adjustable tethers from the right strut side.
And do they go to Shane's bag, right? To my doesn't matter. Doesn't matter. You have a true hot bag, or you?
4 hours, 48 minutes into the spacewalk. All of the attachment bolts have been securely driven by Pesquet and Kimbrough using their pistol grip tools. Next up, the start of the mating of new cables to the ISS rollout solar array connectors. These are connections that could be made while the International Space Station is flying in daylight. However, the eclipse or nighttime pass of the station is required before we mate new electrical cables to the existing large solar arrays on the station, so that we have an integrated electronics path between the new array and the old solar arrays on the port 6 truss of the complex.
Copy your checks, Shane.
We want onto the topmost. It's mated, levers, overseen.
Copy, P1 mated over center.
Okay, P2, 5, no band 10, I band.
Copy, good checks on 2.
Lever is mated over center.
Copy.
And I've retrieved the launch small AET on New York Station. Do you want the cables? Come over to your side. Get me. I don't hear you. You're breaking up, but I'm assuming you cables.
Copy, you've retrieved your adjustables, Choma, and could we get a HECA power cycle and green light check?
Negative, Jenny, just a large small. Just a large small.
Understood.
Small.
Understood, just a large small. Thank you, Toma. Could you power cycle your HECA and check green light, please?
A minute. Shane on the cables. And you want them routed in front of the mid strut? Or? Yeah, that's perfect. Like this? Yep. Okay. Got the cables. Okay, Jenny, power cycle my HECA for you. Off. On.
Thank you, Toma. You can move on to picking up your other adjustable.
For T3, 5, no big 10, Skitty in my van.
Good checks on 3.
Driver is mated over center on 3. Four, no 5, no bent 10, my van.
Good checks on 4.
As we wait for the next nighttime pass of the station, consideration is being given to have the crew press ahead with the release of deployment launch restraints, a pair of bolts that would set the stage for the actual unfurling of the array, taking the sequence of events slightly out of the previously timelined sequence, but we'll get there. Everything is continuing to proceed for the deployment of this second IROSA, or ISS Rollout Solar Array, for the 4B power channel on the International Space Station to join the initial array that was unfolded and unfurled on Sunday during the second of this set of 3 spacewalks.
Do you want me to get the scoop in front of me and do that?
Stand by, Shane. Okay, I have big picture words for both of you. You've done a great job getting our IROSA secure and mating those NZGLs. We have 22 minutes until our working eclipse. So, Shane, you can egress the APFR, and we'll have you do the inventory on the crew lock bag. Thomas, you can get in position underneath the mounting bracket, and we are going to release R9. Obviously, we're not going to push with any other bolts on the base of the mounting bracket.
R9 only. Hey, tomorrow, APR over to you. Yeah, maybe not. No, I don't think I'll use it. Don't need it? No. Wait, I don't see which one. But I mean,
And Thomas, they're going to be in your way, but as much as possible, avoid contact with those NZGLs that are attached.
Copy, Jenny. Hey, Jenny, for crew lock bag 2, are you ready?
Not yet, Shane. We have quite a bit of time here, so I'm going to get you to hold for now. I have additional words for you, and I'll let you know when we can start.
You like to stay frame, Shane? Yeah, sometimes it helps, sometimes it hurts. Make even. Okay. Goes ET back to the bag. I want to make the bag a mess. I don't want to have too many. Right. Welcome to, this is going in the table bag. Yeah, okay, so let's do that.
Okay. Okay, again. Here's the big one. Or small. Here's a small. Nice. Thanks, Shane.
All right, thanks for your patience, you two. We have more big picture words for you. Our PET is just under 5 hours, and our plan is to mate cables during the next eclipse, which is in just under 20 minutes. Following that, we will do 5 minutes of our shunt test, so that's waiting for insulation. We will drive the tensioning bolts, and then we will come inside with pretty minimal cleanup today. That puts us at an expected EVA full length of 7 hours and 10 minutes.
Sounds good, Jenny. Let's do this. Great, Shane. Oh, yeah.
Essentially, at this time, we're trying to minimize your workload and your loading so that we can extend the time of this EVA, because we do have to wait for that eclipse and then that shunt test and insulation.
I understand, Jenny, and we're taking it, The inventory, Jenny.
Okay, I'm going to give Thomas words about R9 first. So, Thomas, you're going to be releasing R9 only. Your settings will be at a Bravo 7 torque. So let me know when you're ready. You can get into a good position to brace.
Working on it. We'll hold off on that.
Shane, we are ready for the inventory when you are.
This is Mission Control Houston. Thomas Pesquet is going to release one of 2 launch restraints for the new ISS rollout solar array. You can see the 2 spacewalkers operating at the mounting bracket to which the new solar array has been structurally attached and bolted into place. We're about 14 minutes away from entering the next night pass, at which time we can begin to hook up the new electrical cables to the existing solar array that you see, the huge P6 solar arrays, to which the new IROSA or ISS rollout solar array will be unfurled to augment power output for the 2B, in this case for the 4B power channel on the International Space Station. On the opposite side, the array that now is augmenting power, about 20 additional kilowatts of power for the 2B power channel, was installed and unfurled back on Sunday in the previous spacewalk, as we have just passed the 5-hour mark into today's excursion. The International Space Station has just flown off the coast of South America, over the Atlantic Ocean, moving from northwest to southeast in an orbit inclined 51.6 degrees to either side of the equator.
A-firm, Bravo 7, counter 2. For Shane, I'm still checking whether anything's missing from that crew lock bag.
Copy. Bravo 7, counter 2. 25.5 program, Jenny.
So good readback on the settings, Thomas. We're looking to release R9 17 to 20 turns. A white line will appear when fully released.
Copy.
Yeah, 20 turns on R9. I see the black line. It's fully released.
Copy. R9 is fully released, and you came in broken. What was your turn count?
The count was 22-0, and the white line is visible.
Copy. 22 turns on R9. You can stow your PGT, Thomas.
It is Jenny, 20 turns.
Copy. 20. Thank you, Thomas.
And one of two deployment launch restraint bolts has now been released. One bolt away from the point at which we can unfurl the array, but not before electrical connections are hooked up to the that will interconnect the new array with the existing P6 solar arrays. For that, we have to wait about another 10 minutes or so until we fly into an orbital sunset.
Initially, and those are now on Thomas' mini workstation. Could you just give us a count on what's on the outside of the bag again?
Jenny, that's negative. Actually, our call before with those tethers, those 280 from the right side of the mounting bracket are now back to the bag. They're on the crew lock bag, the two that were on my side.
Yep, so total on the outside, 2 small adjustables and 1 large small adjustable.
Copy, thanks guys.
One of the ones that was out there initially is on my workstation with the wire tie, that whole setup in my trash bag.
Copy, we're happy with the bag config. All right, and we're still working on next steps for both of you. We think it might be adjusting the MLI and getting in position for the cables, but we're still around 12 minutes away from that working eclipse time period, so we're seeing if there's anything else we can do in the meantime.
Okay, Jenny. The MLI looks better on the right side than on the left side, but we'll fix it on both.
We could offer up still in the crew lock bag. I know we have the scoop still here, but we could put that on our mini workstation. That sounds right.
Copy, Shane. We think that's a really good idea. You can take the crew lock bag and close up the cable bag with it, and we will get you to put the scoop on your mini workstation after deployment.
Idea, Shane. Good idea.
I'll just be right over here.
Yeah. And by 1A, Danny, I don't know if you see in my back view, but on that center plate that the upper strut goes to, there's one bolt that's released M7. I got M5, M6, M8, but M7 is popped out.
Copy, Thomas.
This is Mission Control Houston, 5 hours, 6 minutes into today's spacewalk. Thomas Pesquet and Shane Kimbrough receiving updates from the flight control team here in Mission Control. The ISS rollout solar array you see very clearly at the base of the P6 truss structure, structurally bolted into place on its mounting bracket, as we are standing by for the release of one additional launch restraint, then moving into an orbital sunset, at which time electrical connectors mating the new cables for the solar array to the existing electronics for what is called the legacy solar array wing, or these huge solar arrays you see at the top of your screen that were delivered to the International Space Station back on the STS-97 mission, that will interconnect the new array with the older arrays. They will work in tandem with each other. This process of installing new rollout solar arrays is not to replace the old ones, but rather to augment their power output with an additional 20 kilowatts of power available for station systems and new modules to be launched to the space station.
At the cable bag at this time, we're going to have you retrieve the cap keepers with the caps from the cable bag, and you'll each have one on your mini workstation when we go to do these cables during the eclipse.
Copy. I've got a ret to the crew lock bag on the cable bag. Put that in there.
Copy. Thomas, you can head to Shane to pick up that cap keeper as well. We have just over 7 minutes until our working eclipse time. Okay, I have a cap keeper. Copy, Shane. Once you both have a cap keeper, you can head to your position for the cables.
I'll get one on. I'll cross over to you, but just stay there. I'll come to you.
Five hours, 11 minutes into the spacewalk, about 5 minutes away from entering an orbital sunset, which will trigger the clock, enabling us to hook up the new electrical cables to the existing solar array wing electronics on the P6 truss of the station.
Once you both have your cap keepers, again, we're going to send you to position. We have 5 minutes until our working eclipse. And Thomas will take a glove hap check and gauntlet check.
Okay. Shane, I'm right here. Show the cap keeper. Okay. You have a red on it? I do. It's all yours. I got it. Okay. And you have good gloves, eye up, and gauntlets are down.
Copy, Thomas. Good checks. 30 seconds till handover. Once we're back with you, I'll get one from Shane. We're back with you. I'll take the glove inspection HAP check from Shane, 2 minutes and 30 seconds till working eclipse.
Hold on. I'll get to you in a second.
Take your time.
Jimmy, no change on the gloves and dry hat. As long as you're down.
Copy. Good check, Shane.
Virginia, can you switch cable? We know we're still what we're starting with, and we decide we're connected.
Yep. I'll have to give you a go once MCC goes around the room, but when the time is right, Thomas, you will be starting with P9, and Shane, you will be starting with P7.
Okay, and then we connect the side first.
You'll be mating the wire harness.
Now that we've entered an orbital eclipse or sunset, the ISS flying in darkness over the Earth, we can begin work now, Pesquet and Kimbrough, to begin the installation and connection of electrical cables from the new rollout solar array to the legacy array, the P6 solar arrays that have existed on the station for 2 decades.
And if we are in the case where we do not mate all the connectors during the eclipse, you must maintain a 1-foot keep-out zone from all the demated connectors 2 minutes prior and during installation.
Copy, Jerry. Give me 2 copies.
We're go for cables. Thomas, demate P9 from blanket box power panel P9.
Hey.
Likewise, Shane, demate P7 from blanket box panel P7.
I need demated and have good pins. All the EMI, good EMI band on P9.
Copy.
To connect generate.
You can mate P9 alpha to P9, Thomas.
And P7.
Copy, Shane.
P7 made it, looking at P7 Alpha. Good evening, my band. Good on the side.
Copy, Shane. Mate P7 Alpha to P7.
Memory on this stuff, yeah. Well, I gave me trouble last time. P7 Alpha has made it to P7 with a good click.
Copy, good click, P7 Alpha to P7.
Any next from me, J7 Alpha? Right.
A-firm, I'll need your checks. You can mate J7 Alpha to P7.
Jenny, J9 Alpha is mated to P9 is a good click.
Copy, P9 Alpha to P9. Toma, you can mate J9 Alpha to P9 with good checks.
P9 Alpha to P9, cable to cable. I've got good pins in my band. Solid. Mark. 82, no solid, no bend pin in my band.
Good checks.
And P9 Alpha, like J9 Alpha connected to P9, good click, Jenny.
Copy, Toma. You can move on to P23, demate it from power panel P23.
P23 is demated. Jenny, J7 Alpha and P7 are connected, good click. Mating P20.
Copy, and A-firm, Shane.
Mating P23 Alpha to P23, Jenny, cable to panel.
A-firm.
All right, mated, good click, Jenny. P23 Alpha to P23, cable to panel.
Copy, P23 Alpha to P23. Move on to J23 Alpha to P23, and I'll take your check.
Yes. Yeah, I got P21 Alpha going to P21. No solid. Band 10.
Copy checks.
And on P23, no fraud. In my band, pins.
Good checks, Toma.
And
Working in an orbital sunset period, an eclipse period. Kimbrough and Pesquet have now hooked up electrical cables from the new IROSA rollout solar array to the legacy solar array on the P6 truss of the station. Next up will be the unfolding of the array, the unfurling of it to its full length of 60 feet.
here's one way on this one. Sorry, Jenny, I'm working on this. There's always one that's also hold on the others.
Copy, Shane.
Okay, and J21 Alpha made one. Quick.
Copy, J21 Alpha made it to P21. Understand that that is your last connector as well. Well done, Shane. You can move to securing the strut MLI over the mod kit fasteners.
That's not. Yeah, one more to go, Jenny. J21 Alpha to 10, no side, city in my band.
Understand, Shane. Thank you.
any of the MLIs now. Go to the best of my abilities using the integrated wire ties. Okay.
Copy, Thomas.
My last mate was good. Good click.
Copy. So now that is J21 Alpha to P21, and as you say, your last connector is complete. You can move on to the strut MLI.
You have to be careful from both sides at this time. One up, one down. Wire ties.
And Tomas, say your last. We think you're asking about the strut MLI on the lower strut. Is that right?
Negative, Jenny. I'm talking to Shane. Find what technique works for me. My job by himself.
Understood.
Cable behind your elbow, Shane? It's well done there, buddy.
Well done, both of you. That is the eclipse requirement for this EVA. I'll have you stand by on next steps. Again, we need to wait for Spartan to do the shunt test prior to deploy.
Copy, Jenny. Copy. Should we put the cap keepers back in the bag in the meantime, or go? Likely to use. Well, we can stand by.
This is Mission Control Houston, 5 hours, 24 minutes into the spacewalk. All of the electrical cables have now been mated between the new rollout solar array and the existing solar arrays on the P6 truss of the International Space Station, in this case for the 4B power channel of the station. This is the second of 6 planned new rollout solar arrays to be installed and unfurled at the station at various points on the port and starboard trusses of the complex to augment the power capability of the orbital outpost. We now will have our electrical systems officer conduct a shunt test to measure electrical resistance flowing through the new array before the final launch restraint bolt is released to begin the unfurling of the solar blanket to its full length of 60 feet, and then the tensioning of that blanket.
I can.
You should have a red chain. Thank you. I know from the bag, maybe.
The empty hook right there? No, that's the bag, but that's the bag in.
Bag. We kept the one on the list.
Come on, give me that,
You need?
that right on the corner there, or whatever that is.
Sorry. Do you want me to tether the cap keeper or do you want the red?
No, no. Yeah, let's do the cap keeper in a minute.
Okay. Because you're broken up, so
Sorry, that free hook there. Give it to me, and we'll do it across, kind of cross drop to full hook here.
There you go.
I can't do it.
It's all right.
Hook. Hook.
Got it?
Yep. Good.
Okay.
Oh.
Back.
Look for a hook.
I didn't copy any of it, Shane. I'm sorry, but you're...
Good luck for a hook for you now.
Oh, okay.
Anyone? Gotta get a bunch of reps in there.
There must be a rush. Hey, Jenny, how's it looking?
I have big picture words for you both when ready.
You could use the... you could use a... And if you have a gearing free on an adjustable, you can use one of the hooks of the cap keeper itself, right?
Yeah.
Those cap keepers were those and etc. I'm sure there's a...
That's what I was looking for, was an adjustable.
Yeah.
I'll pull all this out.
Okay, Jenny, go ahead.
All right, we have 17 minutes until Spartan can start the shunt test, so until this eclipse ends. We expect that shunt test will take at least 5 minutes. Right now, your PET is 5 hours and 30 minutes. Limiting consumable, EV2's battery, 7 hours, 53 minutes. What we're talking now is once that shunt test is complete, it'll probably take around 10 minutes for the final bolt and 15 minutes to deploy. Then we need to drive the tensioning bolts. We're thinking about having just one of you outboard during the deployment so that we can get a head start, bringing Shane back closer to the airlock, taking with him the cable bag and maybe an APFR, so being closer to the port CETA cart for the actual deployment. That just makes our cleanup steps easier because, again, we're running close to where we want to bring you inside once the deployment is actually complete. We'll have the details for you shortly, but if you have comments, let us know.
Oh, that sounds good, Jenny. Jenny's retrieving the cap keeper right now. Number 2. That sounds good.
Copy. And Shane, did you copy the big picture plan?
ET copy.
All right, we are going to put this plan into work. Shane, you're going to take the cable bag and bundle it to the APFR in WIF 37, which is the one just inboard of the mounting bracket. You'll bundle those together, put them on your BRT, and then head inboard holding at the port CETA cart.
Yeah, that's an order. Good, and I'm in the APFR for you, Shane. I'm getting the one right there. I'm getting the one. Yeah, 37 is the one right here.
Affirm. Tama, that means that you'll be releasing the final deployment bolt and tensioning the bolts on your own. And you'll also be retrieving the scoop from the base of the mounting bracket and stowing it on your mini workstation.
Good. I can read. And if you give me a...
This is Mission Control Houston. We just passed the 5.5-hour mark in the spacewalk by Pesquet and Kimbrough. Jenny Seide, the spacewalk communicator, Canadian Space Agency astronaut, has been guiding the two spacewalkers through their procedures and the revisions to those procedures. The decision was made to try to maximize and create efficiencies for the remainder of the spacewalk by having Pesquet release a final launch restraint bolt for the newly installed rollout solar array for the 4B power channel on the International Space Station. While he is working to release that final bolt and monitor the actual unfurling of the array to its full distance of 60 feet, followed by the releasing of a pair of tensioning bolts that will enable full tensioning for the array. Shane Kimbrough will begin cleanup procedures. There is a sequential number of events from this point until the end of the spacewalk to ensure that the crew has gathered all of the tools and tethers that they've used throughout the course of the installation of the array and the upcoming events that will lead to its unfurling and tensioning.
RT. Two tomorrow. Say what? Hey, what are you up to? What are you doing? So I'm going to stay here and release R10, but not now, when everything checks out, I think. Yeah, okay. Danny's plan. Use a hand if you're not doing anything. Oh, yeah. On one of these two beasts. Yeah, of course. I'll be right there.
And we agree there's no other steps for Toma until we're releasing that final bolt, and we're still over 10 minutes away. So you two can work together to get Shane in a good config to translate inboard to the port CETA cart.
Absolutely. Awesome. Need to pop it off, but put it on the beard. I didn't copy Shane, sorry. I might need to pop it off the BRT, but we'll see. together and keep it. I just want to put, like 2 straps.
The bag on the good plate, or?
Yeah. When I stow this, easy.
Yep.
So, I don't have the bag yet.
No, the bag is still attached to the structure.
Okay, I've got 2 places it's attached to.
Got one AET on that side to the bag. You can release one, it's still tethered and have a hand on it.
Okay, so one of them, and there's still one attached over here.
There's one on my side.
It's attached as well?
Yeah, it's attached.
And I'm going to undo this one then as well. Both of mine are going to be released, right?
You're breaking up. Did you say both of yours are released?
Yeah, both of mine are released, so do not release yours.
Okay, it's not released. Okay.
All right, it's got one hook connected.
Okay.
One on there.
Side you want?
Oh, there's something on your side.
I'm still connected here.
Still connected?
You want me to release that?
Yeah, you can now, because it's connected to
The FPFR.
Yep.
Okay. So I can release this one, you can use it. All right, you ready? Control the bag, have a hand on the bag. Oh, we have time. Make it nice and snug.
All right, so I've got 2 tied down on 2 places. Still pretty loose, but work.
Get a third one if you want at the corner, but
I have a BRT to car, and I'm ready to the. And I went through there.
yeah, the Mercedes under the handrail, Shane.
Yeah, I see that. I can.
So Shane, we're following that your cable bag is bundled to the APFR. Tomas helping you with the ingress aid, and you're picking up your local and your fare lead, correct?
That's what I'll do here.
Not there yet, Jenny.
I can't get there with the.
I get to the
This takes a little twist. Right twist.
Free. Big floppy bag, watch out on your station.
Yeah, that's a big. Nice and slow. All right, let me get my fair lead here.
Copy, Shane. We have 5 minutes until the end of our eclipse.
Beginning, I have my fair lead. Start heading. Broke up after fair lead chain. Okay, I'm going to head inboard. Peace. Flag on the radiator. For your feet.
Thomas, we can have you get in position for R10. We still have a ways to go until Spartan is going to complete that test. It's over 5 minutes away.
Okay, I'm heading out, inboard, looking good.
Copy. Shane, on your way inboard, remember to undo your fair leads you might have put in and pick up your green hook.
Okay, copy all that, Jenny.
Shane, your green hook is on 5388, and once you get to the port CETA cart, we will be installing the APSR into a whiff.
Copy that, Jenny. And Shane, there's the SSIMS APFR is now really in the way, but it's going to be on your translation route, so don't be surprised. Oh yeah, thanks, Thomas. And I got your safety tether here. I'm feeling clear.
"45 seconds to hand over."
Copy. Copy. Okay, I'm at my green hook location, Thomas. Sounds good. My green hook is connected to my red reel unmarked. Copy.
Back with you.
That again, actually, because I just...
Back with you after the handover.
This one under your tether. What are you saying, Shane? I'm going to redo that because I trapped your tether there. All right.
Ground copies. Sun should be coming up in around 30 seconds.
5 hours, 49 minutes into the spacewalk. We're about to fly into an orbital sunrise and resume work to complete the installation and unfurling of this second ISS rollout solar array that has been structurally bolted into place on a mounting bracket at the base of the P6 truss of the International Space Station. Thomas Pesquet has one more bolt to release, a deployment launch restraint bolt. At that point, we should begin to hear and see the unfurling of the array to its full length of about 60 feet. Following that, there will be the release of 2 tensioning bolts to provide full tensioning for the new array.
Jenny, I think I'm going to have to undo my red hook to unravel this. Put a waist tether down, I'll lock it, and the strap should take it.
Copy, Shane.
That's down. I'm going to release my red hook from my left E-ring there. Route it around the other.
It looks like we just had a good test from Spartan, so that means, Thomas, we can release the final bolt for deployment. Shane, you can keep working your tether and then head to the port CETA cart when ready.
Jenny, those are great news, and I'm ready for PGT settings.
Bravo 7, counter 2.
Bravo 7, counter 2. 25.5 foot-pounds. And how many turns do you want on the 10?
Until fully released, we have written 17 to 20, but last time it was more. A white line should appear when fully released.
Copy.
The electrical systems officer here in Mission Control has given the green light for the unfurling of the new rollout solar array once this final launch restraint bolt is released by Thomas Pesquet. You see him using a pistol grip tool as we speak to complete that work. It should take between 6 and 10 minutes or so for the array to fully deploy. The first array that was installed for the 2B power channel on the P6 truss on Sunday took 10 minutes to deploy.
Hey, Jenny, I think I got the tether cleared up. How are you doing, Jenny? Sorry, Shane. Stepping on you. You're good. That's the IROSA deploy.
Copy. We're watching it, Thomas, and copy the tether, Shane. Thomas, you can stow your PGT.
Now you see the second of the new ISS rollout solar arrays beginning its deployment. Pent-up stored energy in that system enables the array to deploy on its own once that final bolt was released. The deployment beginning at 12:45 p.m. Central Time. We'll see how long it takes.
Danny, I see the 4 magnets together on the right side. I'm going to go check on the left side. If you want.
Copy, Thomas.
I can see them snap together on the left side too, from here.
Great news, Thomas, and from our view, deployment's looking excellent.
Cool. Beautiful.
Shane, once you're at the port CETA cart, we're going to be installing the APFR in the inboard Zenith with 3.
Copy. Yeah, I'm going to minimize the loading to the mounting brackets. I'm going to just stay here. That's fine.
Copy, Thomas. Thomas, if it doesn't impart loads that you're talking about into the mod kit, you can ret to and release the scoop on the base side of the mounting bracket. You'll stow that on your mini workstation. We'll also have you inspect the left strut MLI.
The new solar array, the rollout solar array, the second in the series of 6 to be installed at the International Space Station.
Something, maybe a wire tie needed.
It weighs 750 pounds of mass back on Earth, unfurling to a length of about 60 feet, 20 feet wide, providing some 20 additional kilowatts of power for the 4B channel of the International Space Station.
So Jenny, if I want to go, so you want me to go and modify the MLI on the mid strut, is that correct?
Hey, firm.
It's okay, so I'd rather do this before removing the scoop. I have to go a long ways away and...
Hey, firm, Thomas, you can do it prior to the scoop. We just wanted to take into account you wanting to stay in one spot, but we think adjusting the MLI now is best.
Hey, Jenny, on the Zenith inboard, that's the one you want, correct?
Hey, firm, with 3.
There's no whiff number on it. I can see.
That's the correct whiff, Shane.
Okay, what's the clocking?
12.
The unfurling of the second new ISS rollout solar array continues. The International Space Station flying 255 statute miles over the southern Bering Sea.
That's 12 o'clock, Jenny, black on black, good pull and twist test.
Copy, Shane. That is a good APFR install. I have other settings for you when ready.
Let me get this other bag off first.
Copy. And for both of you, deployment is still looking great, and we are getting good power from the solar array. So we have a lot of happy faces down here. Well done, both of you.
The electrical systems officer here in Mission Control reporting a good power generation from the new array, even as its unfurling continues.
From the front. I fixed it a little bit. It's better than it was.
Understood, Tomas.
Hope you're happy.
Yep, all we're looking for is best effort, so that looks good to us.
Okay.
And Tomas, we're still deploying. Your next steps will be to get in position for the blanket tensioner bolts, R11 and R12.
Okay, so I think that's one more reason to keep the scoop for now.
Yep, you'll need to retrieve the scoop before going back inside, but you can do it after the blanket tensioner bolts as well.
Okay. Deploying. Hey, big Shane. Good, I'm just unbundling the cable bag right now. Looks like the deployment is complete, Jenny. I see the mandrel from a different color, and the motion is stopped.
Copy, Thomas. We're doing our final check.
The second ISS rollout solar array now fully deployed.
Okay, Thomas, you are
We're
right.
double checking the dimensions. It appears to be fully deployed, and it took 10 minutes again, just as the first array did back on Sunday.
Ready for setting, Jenny.
Alpha 1, clockwise, or counter, excuse me.
Thomas Pesquet now will use a pistol grip tool to release two tensioning bolts that will provide full tensioning for the newly deployed blanket. And at that point, the crew will begin cleanup work. So everything went exceedingly well with the installation and deployment of this second ISS solar array, the rollout solar array, the second of 6 to be installed at the International Space Station.
Indigo, Fox 11.
All right. R12 release, stopped out, Jenny.
Copy, R12 released.
Ready for R11, is that the same settings?
Tell them what they were. What are they?
Hey, Jenny.
Okay, Thomas, we're ready for you to release our 11 as well. And Shane, no more action with the APFR. We can continue inboard.
Okay, Jenny, same settings on R11. Question from Thomas.
Affirm, Alpha 1, counter 2, same settings.
Alpha 1, counter 2, R11, work. Jenny, I have 4 turns, and I can confirm on both sides the tension mechanism is released.
Copy, 4 turns. R11 is released. Well done, Thomas. You can stow your PGT and retrieve that scoop.
North. Tom, at DMT, heading back. Copy.
Flight controllers here in Mission Control now report good tensioning on the newly deployed solar array blanket.
Hey, Jenny, how's that scoop?
Copy, Thomas. Great work. You can stow that on your mini workstation. Just so you know, you will not be retrieving any APFRs for your cleanup steps. We're just going to have you translate inboard, pick up your green hook, and pick up the crew lock bag on the FSE.
Copy. How you doing, sir? All good? Good. I'm just past the starboard seat cart. Heading into. Well done out there, buddy. Yeah, that was fun.
Again, great work, you two. Our PET is now 6 hours and 9 minutes. Limiting consumable, still EV2 battery, 7 hours, 53 minutes.
Just waiting back. Let's look at the work site, looks clean, we left nothing behind. I'm on my way.
Copy, Thomas, that you are headed inboard. I'm back with you after the handover. Before that handover, I gave you a PET of 6 hours, 10 minutes, and limiting consumable EV2 battery, 7 hours, 53 minutes.
Copy. I'm back inboard now, Thomas. Now I'm coming back inboard. Past your APSR. It stays there.
Good words.
My green.
Copy, you're at your green hook, Thomas.
I'm going to see the spur. Ready for your words.
Copy, see the spur for Shane.
Jenny, I'm guessing I'm picking my green hook and I'm passing it to my red reel. Is that correct?
Affirm, Thomas, you'll be picking up your green hook, and then we have you picking up the crew lock bag at the FSC.
Yeah. Okay, my green hook is on my red reel. Red reel is unlocked. My yellow hook is locked on my green reel. My green reel is unlocked. And the red hook is still on my left gear extender. Locked.
Sounds good, Thomas. Continue inboard.
Thermal cover is open.
This is Mission Control Houston, 6 hours, 13 minutes into today's spacewalk by Shane Kimbrough and Thomas Pesquet. Mission accomplished with the second of the new ISS rollout solar arrays having been fully unfurled and tensioned into place, now providing additional power for the 4B power channel on the P6 truss of the International Space Station, which is currently crossing the border between Colorado and Oklahoma, moving from northwest to southeast in an orbit inclined 51.6 degrees to either side of the equator at an altitude of 255 miles. The two spacewalkers executed today's activities in flawless fashion. All the hardware cooperated. Their suits behaved perfectly, and everything has fallen into place with two new solar arrays now deployed at the station, 2 out of 6. The next pair that will be launched on a future SpaceX cargo flight will be designed to be installed on the P4, the port 4 and starboard 4 trusses of the station to augment power for the 4A and 3A power channels on the International Space Station.
Mine, Jenny, I have my waste toter connected to the airlock waste toter, closed and locked on all 4 hooks. I have a good load path to the airlock.
Copy, Shane.
And here in the flight control room, the electrical systems officer, who goes by the call sign of Spartan, reports great power generation from both the new and old solar arrays on the P6 truss. Everything has performed perfectly to this point. Good power generation from the 2 new ISS rollout solar arrays.
We're still talking about picking up that APFR, which is at the airlock, the one which is on the WIFX and which is sticky. That's what's giving us pause on your next step, Shane. So I will just put that to you, see how you guys feel. Understand, Thomas, you still need to pick up the crew lock bag, and you'll be bringing in the safety tethers as well.
Yeah, I'm nowhere near the airlock right now. I have time to do it. I think I'll reach on this, right?
Shane, my understanding is you should be able to reach it because of the daisy-chained waist tethers, but I'm getting a final check for you.
Yeah, I'm on the FSC.
Copy, Thomas. It should give you the reach, Shane, in order to reach the APFR.
I'll give it a shot.
We appreciate it. Thanks.
Back with our downlink video capability from the International Space Station, Shane Kimbrough doing some cleanup work. He and Thomas Pesquet now will begin the process of gathering tools and tethers, other equipment used in today's spacewalk as they slowly make their way back toward the Quest airlock to wrap up today's excursion, the third in 9 days for this pair of spacewalkers. This was the 9th spacewalk out of the International Space Station this year, the 9th in Kimbrough's career, and the 5th for Pesquet, all of them having been conducted with Shane Kimbrough, the first 2 spacewalks for Pesquet, and occurring in 2017 with Shane Kimbrough.
Yeah, I have a tether on the APFR, Jenny, you just want me to release it and put it in the airlock, correct?
Affirm, Shane. We're just bringing that inside to do some tests on it.
On Tomas. Doing good. Okay, on that scoop. On an EDT. Throw it in the bag and then bag.
Ground copies, Tomas.
Okay. Jenny, the APFR is added to the airlock.
Copy. Great work, Shane.
We got that thing in here for you. Yeah. Torque sheet.
All right, Shane, and I have confirmation now that you have stowed that APFR, you can ingress the airlock.
Okay, Jenny, I'm in.
Sounds good. Well done. Shane, you can turn off your HECA if not already complete.
Okay, it's off. How you doing, Tomas? Doing good. Retrieving the bag now. My BRT, my BRT red. I'll go ahead and stow that behind me. Okay. And I'm going to head back to the airlock.
Copy. Thomas, on your way inboard, make sure that you press the inboard CETA cart brake releases on both the port and the starboard cart twice.
Copy. Place on the inboard CETA carts.
Affirm the inboard brake release pedal on both CETA carts.
Copy. Okay, actually twice on the
Copy.
port Chia card. Making my way under the MT. The starboard Chia card. How you doing, Shane? Good? I'm in the airlock. I'm all good. Alright. Starboard Chia card pedals, you press twice.
Copy. Thomas, your next steps are at your anchor hooks.
Okay, I'm at the anchor hook settle point.
Copy. And Shane has a good load pass to the airlock, so on his go, you can remove his anchor hook from handrail 3651 and attach it to your red reel where your green hook is attached, or your waist tether.
Copy. You have your go. You have a go. Alright, Shane, your yellow hook is there on my red reel. Locked, black on black. Red reel is unlocked.
Copy, Thomas. You can retrieve your anchor hook and stow it on your mini workstation.
My anchor hook is on my mini workstation, Jenny.
Copy. Continue your translation to the airlock.
Shane, are you hooked up to the STU or not? No, I'm not. No? He's on that call. Okay. Never. Yeah, no hurry.
Regarding the SCU, there's no pressure to get on it as our consumables are in good shape, and we just want to give you lots of flexibility to maneuver in the airlock with the APFR in there. So it's up to you.
Good, Jenny. Send you a call. Yeah, I'll go ahead and do it now.
We copy, Shane.
AFU is on and locked.
Copy, Shane.
I'm going down to see a spare, Jenny.
Copy. Tama, we see you almost back at the airlock. You'll be handing in your crew lock bag to Shane.
Shane, I'm at the airlock. All right, welcome back. Thank you. Here's a crew lock bag. Clear. Your TCL attached to it, sorry. Fair enough. What? You want me to let it go? I can't hear what you say. You want me to let it go so you can get it? Yeah, no, that's good. You can put a wrap on it. Yeah. Put a wrap. Okay, I'll release my BRT. I have the bag. Yeah, and can you release my BRT? Yep. Right? Sure will. Thank you. Thank you. Yeah, there you go. My journey that is complete.
Copy, Tama. You can turn your HECA off and ingress the airlock. When you do so, verify the forward hatch pit pins engaged.
All right, there's looks good. Forward pit pin is engaged. No problem. Work on my HECA. Now, Jenny, that wire tie stays outside, or do you want me to bring it back in?
That'll stay outside.
Yep. Shane, I'm going to ingress. If you can scoot as much. I'm forward, and the bags are aft. Okay. Plenty of room. Keep the bags. Okay, I'm in. Well, I'll grab the thermal cover.
Copy.
Okay.
Tama, attach the hook to the magnetic D ring, cinch the strap until snug, and report the number of Sharpie lines visible.
Okay, good work. And my legs change down towards the maker. Pull them down? Yeah. Try it. How's that? Good. Thanks. We're pulling me back out. Line 6 line visible. You copy, Jenny?
Say again, Thomas.
Line visible.
Thomas, we need to check the clearance around the thermal cover closure. We're tracking that there might be something interfering with the magnets. We understand the strap.
No, it doesn't close. It just doesn't. Just like the previous 2 days. It doesn't stay closed. The magnets don't do their job. And the AT, you cannot, it's fully cinched. Every time.
Thomas, there is a strap which is just outside. Could you pull that in? Thank you. You got it.
Actually, the strap of the D-ring doesn't change much, Jenny. If you breathe, it opens.
That is a good config now, Thomas.
Okay.
Thomas, you can connect to your SCU.
Where's my SCU? You're right there. No. I think it's between my legs right here. That's what it is? Yep, that's it. Okay, got it. Connected to the SCU.
Copy. With both of you on the SCU, a note, a TCV setting of 8 max cold minimizes time for SCU cooling. You can both switch water off, forward, expect H2O is off message.
Copy. V1, H2O is off.
This is Mission Control Houston, 6 hours 37 minutes. The clock's still running on today's spacewalk. A view inside the equipment lock section of the Quest airlock as Mark Vandehei, closest to the hatch, and Station Commander Aki Hoshide from the Japan Aerospace Exploration Agency await the closing of the hatch and the start of the repressurization of the crew lock section of Quest that will mark the official end of today's spacewalk. Our coverage will continue through the point at which the crew is back inside the equipment lock and their helmets are removed. Everything has gone splendidly with today's excursion, the 241st in the history of the International Space Station, with the second of the new ISS rollout solar arrays having been installed and unfurled in perfect fashion. Everything went like a charm, and both the first array that was installed and deployed on Sunday and the second of these 3 spacewalks by Pesquet and Kimbrough and today's activities have produced 2 healthy arrays that are now generating 20 kilowatts of power apiece to augment the power capability of the International Outpost.
Thank you. Well done, Mark and Megan. That was really good. Incredible. Unbelievable.
Okay, I'm tracking. Your 2-minute timer is up. So, Thomas, verify the outer hatch is clear of hardware and the handle position is per the hatch decal.
Okay. Outer hatch is cleared of hardware and the handle is per the hatch decal.
Close and lock the hatch.
It works. Thanks, Shane. Nicely done. And the hatch is notched and only is locked.
Copy. Hatch closed and locked. Shane, on the UIA, check oxygen for EMU 1 and 2. Both valves should be open.
Both are open.
The hatch to the Quest airlocks crew lock section is now closed.
Copy.
The two spacewalkers, Kimbrough and Pesquet, on the other side of the hatchway to the equipment block. Mark Vande Hei now joined by Megan MacArthur, who drove the Canadarm2 robotic arm with Pesquet at the end as he carried the new ISS solar array, the second of these two new rollout arrays, to the P6 or Port 6 truss worksite, where he and Shane Kimbrough worked to structurally install the new array onto a mounting bracket at the base of the P6 truss, and then worked with bolts and tensioning mechanisms to help unfurl the array and get it fully tensioned.
Okay, copy. With that, I will hand you back to your very capable suit IVs. Thanks again, everybody. Great job today.
Thanks, Jenny. You're welcome. Thanks, everyone.
All right, gentlemen, fantastic job. We're looking forward to getting you back inside. The next step to do that is go put your O2 actuators in.
Oh, you see it. Attention. Oh, I see it. See you get EDT. Press.
Copy EV2 in press.
EV1. Press.
Copy EV1 is in press. Toman, check that the EV hatch MPEV is closed.
By Marcus in press. The press position.
I'm sorry, Toman, I think I copied you said the O2 actuator is in press for you.
Yes, correct.
Okay, now Thomas, check that your EV hatch MPEV is closed.
Yeah, MPV is closed.
Okay, I'm going to start repressing. It's going to be very loud for us. We won't hear you as well as you can talk to each other. So if you need me to stop, give me a closed fist in the window, Shane, and Thomas, you'll have to tell Shane if you need that.
Okay, Shane, if I'm squeezing your feet like crazy. Okay. You can talk to me.
All right, here we go.
Stopping at 5, Mark.
Sorry, say again?
Stopping at 5.0.
We'll give you a warning before we get to 4, and then we'll tell you when we're stopping at 5.
Copy.
This is Mission Control Houston. The repressurization of the Quest airlock is underway, marking the official end of today's spacewalk at 6 hours, 45 minutes. The spacewalk ending at 1:37 p.m. Central Time, 2:37 p.m. Eastern Time. Again, repressurization of the Quest airlock's crew lock section underway, marking the official end of today's spacewalk at 6 hours, 45 minutes.
All right, gentlemen, when we get to 4 PSI, you can expect an alert tone.
Copy. Copy.
Okay, we got to 5 PSI. The IV hatch equalization valve is now off. We're going to wait for 2 minutes for the crew lock pressure to stabilize. And you should expect an alert tone.
Copy. Copy.
All right, gents, we had our 2 minutes for the crew lock pressure to stabilize. We're checking the pressure right now. We're going to wait another minute to make sure it doesn't change too much.
Copy. Copy.
Okay, gents, we had a good leak check. You can take your glove heaters to off.
Off EV1, off EV2.
Check your gloves for contamination and report to Houston.
All right, EV1, I have no glove contamination, good gloves all around. Same for EV2.
Copy. Both of you take your O2 actuators to IV.
This is Mission Control Houston. The repressurization of the Quest airlock is continuing in good fashion. Shane Kimbrough and Thomas Pesquet safely back inside following a 6-hour, 45-minute spacewalk today to install and unfurl the second of the 2 new ISS rollout solar arrays. We have statistics for you. This was the 241st spacewalk in support of ISS assembly, maintenance, and upgrades. The 9th spacewalk conducted out of the International Space Station this year. This was the 9th spacewalk in Shane Kimbrough's career. He now has a total of 59 hours and 28 minutes of spacewalking time, which ties him for 6th on the all-time list with Russian cosmonaut Fyodor Yurchikhin. Thomas Pesquet now with 5 spacewalks to his log, a total of 33 hours even of spacewalking time. The 241 spacewalks in ISS history now have totaled 1,519 hours and 41 minutes, which is the equivalent of 63 days, 7 hours, and 41 minutes of spacewalking time. And we just received this photo from NASA headquarters photographer Joel Kowski, who shot the International Space Station in transit across the sun during the course of today's spacewalk. A dramatic view of the International Space Station while Shane Kimbrough and Thomas Pesquet were conducting their work outside of the International Outpost.
Yeah. Oh, I'm just hanging.
Okay, when the DPDT becomes approximately 0, you can expect an alert tone.
Copy. Sounds good. I'll keep the APFR out of the way.
The Quest Airlock's crew lock section now has been repressurized. We'll be standing by for the opening of the hatch and for Megan MacArthur and Mark Vanderheide to assist Shane Kimbrough and Thomas Pesquet back inside the equipment lock. Again, the spacewalk concluding at 1:37 p.m. Central Time, 2:37 p.m. Eastern Time at 6 hours 45 minutes.
Houston, airlock on Space to Ground 1. We're ready for your comm reconfig and step 4 of closed CVA.
Houston copies. That is in work. I'll call you when they are no longer hot mic.
Copy, thanks.
Shane Kimbrough now back inside the equipment lock with the hatch open. Thomas Pesquet waiting his turn.
Airlock Houston, Space to Ground 1 crew is no longer hot mic.
Copy, thanks.
This is Mission Control Houston. The two spacewalkers, Shane Kimbrough on the left, Thomas Pesquet on the right, have now had their helmets removed, safely back inside the equipment lock section of Quest, wrapping up a flawless 6-hour, 45-minute spacewalk in which they installed and unfurled the second of the two new ISS rollout solar arrays for the 4B power channel on the International Space Station. So over the course of the past 9 days, the two crew members from Expedition 65 conducted 3 spacewalks to install the first pair of what ultimately will be 6 new solar arrays to augment station power capability, 20 kilowatts apiece from each of these new arrays. With that, we'll begin to wrap up our coverage here with a couple of programming notes. The end of today's spacewalk is just the beginning of a huge amount of work over the course of the next several weeks aboard the International Space Station. Next up will be this coming Tuesday, June 29th, a doubleheader on tap. The SS Katherine Johnson, Northrop Grumman's Cygnus cargo craft, is scheduled to be released by robotic ground controllers here in Mission Control with our NASA television coverage beginning at noon Eastern Time this coming Tuesday. The release time, 12:25 p.m. Eastern Time. Cygnus will spend 2 days transiting for a deorbit on the night of July 1st. Later that evening on Tuesday, June 29th, we'll carry live coverage from the Baikonur Cosmodrome in Kazakhstan of the launch of the unpiloted ISS Progress 78 cargo craft by Roscosmos, with our coverage beginning at 7 p.m. Eastern Time, a launch scheduled at 7:27 p.m. Eastern, which will be 4:27 a.m. Baikonur time on June 30th. That will lead to a 34-orbit transit for the new resupply ship that will be loaded with almost 2 tons of food, fuel, and supplies for the crew members aboard the International Space Station, and the first ever docking by a Progress to the Poisk module on the space-facing side of the International Space Station. The docking is scheduled on Thursday, July 1st, with our coverage beginning at 8:15 p.m. Eastern Time. Link up the automated docking scheduled at 9:03 p.m. Eastern Time. All of that coming up on NASA television this coming week. And we always urge you to follow all of the activities for the crew members on board the International Space Station on our website at www.nasa.gov. So with that, we'll conclude our coverage today, a 6-hour, 45-minute spacewalk by Shane Kimbrough and Thomas Pesquet. 2 new ISS rollout solar arrays now complementing the power capability of the International Outpost. With that, we'll call it a day. Have a great weekend and a safe weekend. All the best from us here at Mission Control in Houston.
Thank you.